Okay, let's get started. Hope everyone is fine. Did you all try the paper? Did you all do the flipped exercises suggested? Compare and
Yes, sir.
contrast. Okay, let's go one at a time. Whoever wants to speak, raise your hand. We'll go one at a time. So, yes, sir. Who was that? Okay, how did you find this GATE BM 2022 and the mock test? What were some differences you observed? Can we have some comments on that? Wait, thanks, but we are unable to hear you. In fact, even the mock test will perhaps come to that in a while. But how was last week's session? I heard it was good. It was informative. Many of you had so many questions and all that. Uh, yeah, that's the feedback I got. Any comments from your side? How was it? Was it useful?
Yes, it was very helpful.
Oh, thanks, Sornendu. Yeah, in fact, I just received a message from Madangi that she accepted an offer from IASC in product design and engineering. Very hard to get in, and
Yeah, she was telling that she had appeared for the seed exam.
yeah, it's very
Yeah.
very hard for engineers to get through the seed exam. Okay, for artists, if you're attending to graphic design and all that, it might be easy. For engineers, it's very hard through seed. But
Right.
she managed to get in through GATE. It's an excellent program. We'll come to that, but I just heard that news. Yeah.
Yeah, it's a great news, so congratulations to her.
Oh, yeah, sure. Yeah, we feel good, and of course, hoping to see you in similar positions. In fact, some students told me even with very low ranks, they were getting calls from material science related to biomaterials, medical imaging, and informatics. So things are sounding very good. I hope all of you who are here who enrolled will be in similar position sometime this time around next year. And towards that, let's start working. So let's get started with this mock test, compare and contrast GATE BM 2022. What were some differences between the mock test and the GATE 2022 paper? Any comments? One or two differences? Okay, was it easy? Was it hard? So what we'll do is, okay, how many of you think easy? Please type in the chat. How many of you think it's hard? Can you all hear me? Okay, we are starting, we get one response. Aptitude section is easy. Yeah, feel free to, give a brief comment either in the chat or feel free to talk. And, did you all also get to play this icebreaker game? Did you all get a chance to speak? No, the class is not really moving forward if it remains this way. So we can we can stop at this slide, and until we pick up pace, we'll wait for that.
Sir, everyone spoke in the previous session.
Okay, everyone spoke in the previous session. So somehow I am the deterrent. I am like the one who is spoiling the party here. I suppose not. I really want you to want to encourage you all to speak. Yes, Bono.
Sure, sir.
Okay, thanks for Nindu. The thing is, only requirement: be courteous. More than being courteous to me, be courteous to the students, other students out here. That's the only requirement. Other than that, feel free to talk. interrupt, challenge, all that is fine. It's okay to ask silly questions. It's okay to make mistakes. Even professors may not usually agree this, that they may make mistakes, but I do agree. Sometimes mistakes happen, sometimes errors happen, and all that. All that is fine. Okay. Uh, all that happens in the learning process. We should be able to correct it, go past it. That is what is more important than being embraced about, or being feeling silly about a comment or question. Okay, I really want the class to be more interactive, and let's try it for a couple of slides. And to help it, we'll go alphabetically initially. Okay. Akansha spoke up. Urvi, at least I heard her voice. Benaruth, what did you think about the mock test and the GATE 2021 paper? Oh, this
It
is
was a
supposed. At least someone can point me, right? This is 2021. Contrast GATE BM. This is 2020. Okay, Benaruth, your comments.
it was like okay, sir.
It was
Not too difficult or too easy, sir.
not too difficult or not too easy. Okay. Yeah, in fact, for example, if it's like I'm referring to 2022, you might like interrupt me, hold on, what is going on here? What is 2022, right? At least basic things. Okay, so thanks, Venerat, even thanks, Akansha. Okay, now, Jakrudi, did you do this map questions to syllabus in the topics? Were you able to do it, at least for 50% of questions? Okay, so we are all working with some technical issues here and there. Mics are not working, I suppose. Yeah, all this happens over the course. We'll settle things faster. Jiva, very able to map questions.
Yes, sir. Hello, sir. Good evening, sir.
Yeah, good evening, Jiva.
Yes, I have mapped the questions for GATE 2021 as well as the mock test questions, similar questions which we asked in there. Some of the few questions were area of unshaded portions, and then directional derivatives from mathematics, and then Fourier transform, scaling and shifting process. And some more from microprocessor as well as anatomy and physiology. More was related on second order system of step response and undamped overdamped. Most of the questions were from this when I found in the mock test based on control systems. Yes, sir.
Okay, thanks, Jiva.
That's it, sir.
Okay, that's it. I only have one question. You said microprocessor architecture. Is it 2021 paper by any chance, or the mock test?
2021 paper I found microprocessor questions. In mock test there was like only one question regarding the resistor which should be there in the position. It was asked to find the resistor which should be there.
I see. I'm not able to connect the question, but anyways, okay. Then let's go to Jyoti, Kishore, and Mega R. So, were you able to solve some new questions, or find after the mock test? Were you able to solve it? Say not during the 3 hours, but say during the interview or later after the interview, something like that.
Sir, after the interview, I was able to solve certain questions. Like you gave me idea about how to solve certain questions, so that those questions I tried.
Okay, great. So
yeah, same sir. Like I did some silly mistakes that you told me. Like there was some tricks and some questions that I did some silly mistakes that you corrected after like in interview.
okay, excellent. So yeah, first thing, notice all of you have actually tried the paper, which is why we are all sitting here discussing the solutions. So you have already done the flipped activity, the bare minimal thing. So more things is only going to benefit you more. So yeah, this is from the previous slide. So let's start solving problems. One at a time, we'll go serially. Okay. Okay. Is there anyone who is not able to solve this problem right now in the class? It's okay if you still don't know that. At least you can privately text me that I still don't know, and we'll try to discuss. Where are we with respect to this question? I suppose all of you are able to solve this, right?
Yes, sir.
Yes, sir.
Yeah. Notice, in fact, if you Google the first 3 questions, you might come across many interesting facts behind the first 3 questions in the mock test. We will not go to that, okay? But the objective of having this question first is you want to be able to convert English, in fact, or text to basic math equations, okay? This is a very, very key requirement. For example, bat and ball cost ₹11 in total. Let's say bat is X, ball is Y, X plus Y is 11. That's what this means. And bat costs 1 more than the ball. And so let me make it explicit. Bat, ball. So our bat is 1 more than the ball. X is Y plus 1. Is this correct?
Yes, sir.
Yeah. Now we have 2 equations and we can solve for that. Just plug this thing here and we can find what the cost of ball is. So this ability is a must, and this ability, it can be very, very explicit, straightforward, as in this example, or things can get really tricky. There's just one detail. Converting English to equations can get tricky as they get deeper into many subjects. But always notice you're making this one simple step, and acknowledge this step, and you should be able to easily answer many questions. So this, I suppose, all of you could answer. I don't have to explain here. This thing, let's get to this question. There were lots of confusions during the interview. Even I was starting to get confused many a times. So time, work, and effort, those problems are slightly tricky, but how about this thing? Now things make sense. We assume all these machines are working parallelly. So this means one machine makes 1 box in 5 minutes. Is there anyone who doesn't agree with this? All of you agree? Banu?
Yes.
Okay. So then it's a matter of scaling things. How would 100 machines make 100 boxes in dash minutes? Answer is evident. They are all working parallelly. Each machine will make 1 box. It will take 5 minutes for each machine. So answer here is 5, which is evident once you put things. But let's ask a very different question. This problem we can all solve. How can we modify this question? Let's go, again, let's go alphabetically. Where did I miss? Let's start with Megha, yes, and Nandini, Parmar, and Prabha. How can we modify this question? Like, say they repeat the same question next year in GATE, or I rephrase this question. What are some approaches we can do that? Megha, yes. Nandini.
Change in time, sir.
Changing time. Yeah, one simple thing is okay. Now 5 missions, 5 boxes, instead of 5 minutes, it takes 10 minutes. What is the answer here? Still 10 minutes. Okay, instead of this 100 missions, 100 boxes, how about 200 missions, 200 boxes? All those again we can answer. How do we make 100 missions, 200 boxes? Does that slightly make it, first question, complicated? Is the problem still solvable? Let's say 100 missions make 200 boxes. How much time does it take? Can we all answer that question? So the question is now 100 machines to make 200 boxes dash minutes. Can we answer this question?
Multiply by 2.
Multiply by 2.
Yes, sir.
Yes, essentially now you notice it's a simple ratio proportion problem. So we can also deal with, varying number of machines, varying number of boxes, right? Instead of saying this, so now there is a slightly, I'm going to ask a trick question. How about, will this multiplying always work? Anyone can answer. Will that multiplying always work?
No.
When will, for example, when will it not work?
When they both are not multiple of each other, like it is 100 and 200. When it is 100 and it is something like 35, so they won't be multiple of each other. So I don't think so that multiplication will work that time.
Okay, that multiplication will work that time. So okay, that is correct. So we need something better than approaching this problem using this one statement, which we did for this. Okay, so we will do that subsequently. But here there is a very tricky special case. Okay, we will generalize this properly in aptitude session, but here is a very special case. How many 100 machines, 50 boxes, dash minutes? Can we all type in the answers for this? No, chat, you can easily at least look at others' answers and type. So this is a slightly tricky question. Okay, 5 by 2, 2.5. Let's say 100 and let's say 75 missions. Something like 225 boxes, dash minutes. We just noticed this problem is, again, we can address this. This problem we can address, okay, but this is slightly tricky. Are all these machines working parallelly? Can more than one mission work in a given box? Can like two missions work in making one box? How many of you say again, instead of missions we have students, instead of boxes we have problems? Say two students working in a problem in an exam. Does it make sense?
No.
No.
Right. Yeah. So in this case, notice there are additional factors to be considered. Of course, now we need extra phrases here. Two missions, more than one mission can work in a box. If that is given, we have to approach this differently. Or okay, that is not given. Then best is one mission can only work at one box. So 50 missions should not be used, right? Based on that, they should still take 5 minutes. Notice the answer starts changing. Okay, and simple ratio proportion doesn't work. And if Gates decides to trick you, this is what it does. Okay, there will be additional clauses here. They will try to make it precise, and they can make questions tricky. So let's take a step back. Very, very basic question. Okay. As you start, whichever question you are able to solve, try to modify it and see if you are able to solve it. We'll get into advanced details, very hard problems towards the end. But for a start, can you start questions that you can currently solve? Can you start modifying it and see how you can make it more easier, more difficult? Is that possible for you?
Yes, sir.
Okay.
Yes, sir.
That is a
We
very,
will
very
try,
effective.
sir.
Yes. So start trying that. That's a very effective way of learning. So start framing questions yourself. And of course, you will get help to do this systematically from the class. Okay, let's we spent enough time with this question. Let's move on to this question. I presume everyone here can also answer this. The idea is simple. We have x at some particular day. The next day, it's going to become 2x. That means the previous day it will become half x. Because if it's half x here in one day, it becomes x, right? So if it is like in 48th day, if it is full, the previous day it should be half full. But notice the simple logic, many of us were making a mistake. Okay. There is more to this question from a strategy point, how we approach it and all that. But let's not get into that and make this, even more complicated. So this question, many of you told me you don't know probability density functions. We will introduce that and all that. But right now, do you agree? The symbol here means we are looking for probability. Okay, what is the probability of x greater than 1? So let me also plot things so that things make more sense to you. We are given a function f of x. Notice it's exponential. How should this function look like? Is it 0 anywhere? Is it like infinite anywhere?
It's an exponentially decaying function.
Exponentially decaying. Great.
Starts after 1, I think so, because the probability we are going to find after 1. X is equal to 1.
Yes. So it's exponentially decaying. And notice if you substitute x is 0, we have 1 here. That also makes this integral from 0 to infinity 1. Okay, that is the coefficient here is 1. Because it's a PDF, notice it's defined only in this range. This function is 0 here. Okay, it's 0 before less than x less than 0. It's only non-zero for 0 for positive values of x, 0 to infinity. And in that range, it's exponentially decaying. And because it's a PDF, we know 0 to infinity, f of x should be 1. Do we all agree with the limits here? Why it's not minus infinity? Because it's only defined here. Do we all
Yes,
agree with
sir.
that? In fact, this question, even if some C were given here, we can still answer this question. Do you agree? Because we can find the C enforcing this condition.
Yes, sir.
Okay, great. And so let's get to this. All this says is what is the probability, of x being greater than 1? So x can take all these values. What is the probability that x value is in this range? That is above 1 in this range. And essentially it says we are looking for, given this function, we are looking for the area under this thing. That is what the probability is, or that's what the meaning of a PDF is. So can we all find this area?
Yes, sir.
Right, it's just 1 to infinity f of x, which is e power minus x dx. Okay.
Yes,
So
sir.
I suppose no questions here that the integral 0 to infinity should be 1 because it's a PDF, and then the answer we are looking for is essentially this integral. Of course, we will try to do integrals like this. How many of you have issues with doing basic integration? If you have issues, again you can email me or even privately reply me. Not a good state to be in, but still we have time to work on it. But I suppose everyone agree with us, can do this integral. Is there anyone who has trouble with this exponential term? No, right?
No, sir.
Okay. Even if there are issues, message me. We can work on that. That is my major point. Okay. And if you do this integral, I think you should get the answer. But there was a very smart student here. You said, I know this is an exponential decaying function. I am looking for this area. Is this area going to be higher or is this area going to be higher? In fact, if I were to draw it, properly decaying, so which area do you think will be higher? Kind of goes like this. It really decays very fast. So is this area higher? Is this area higher?
The first one is higher.
Yeah, this area is supposed to be higher. So certainly this answer doesn't make sense. Unlikely to be even, certainly not 1. This area is supposed to be higher, which means the answer is likely A. Without even doing this integral, one student said that, if you draw this according to scale, you can actually answer this. That's a very smart answer. In fact, you have a good way to answer a gate question. I eliminated 2. Doesn't make sense, it's equal. Certainly not 1. So why not pick one among these 2? I might as well go and select. Even otherwise, this area is likely to be higher. So the smaller area we are looking for is this option. Interesting, right?
Yes, sir.
Yes, sir.
Okay. So yeah, that is one quick shortcut to answer this. So in fact, notice with this shortcut, you actually don't have to know the integral. So we are fine even if some students struggle with integrals. We'll try to work out, loopholes and all that. Let me move on to the next question. Some of you said you had trouble with this question. Is anyone still, do you have trouble with this question? I want to spend more time on important questions and not, simpler questions. Is there anyone who has trouble with this question? So in GATE, I think they asked for the shaded region. I asked for non-shaded region. Okay. The silence kind of slightly bothers me. Again, let me go alphabetically. Where did I leave? Let's start from Shubham. Hi, Shubham. Shubham, Suman. I think Swarnendu. Can you, we'll skip Swarnendu for now. Shubham and Suman, can you try to answer how to find the shaded area?
Sir, may I answer?
Yes, please. Yeah.
Sir, first we will calculate the overall area of the square.
Mm-hmm.
Then we will calculate the area of semicircle,
Mm-hmm.
which is pi r square by 4.
Mm-hmm.
Then as we can see, there are, if we complete this semicircle, we are having 2 semicircles here. One is a P in between PSR and another one in PQR. So both are having pi r square by 4 area of PQRP.
Okay.
And in this side PSRP. So if we calculate this, we have to subtract the area of the semicircle, total of the semicircle, from the area of the square.
Okay. Okay. So there were some couple of issues with the words we used. This is not a semicircle. Okay. So semicircle is something like this. But I think your approach is correct. In a full circle, if you cut it half.
Oh, sorry, sir. Quarter of the circle it is.
Yeah.
I was saying semicircle.
Yeah. That is fine. So, I mean, your answer was good. It's just that basic word mismatch here and there. So this is a semicircle. Quarter circle would be this. Because a couple of students seem to have problem. Let me explain this. Quarter circle. Semicircle, quarter circle is this, right? Notice that is what over here and T, S, R, right? It's a quarter circle. And if you take this quarter circle, if you subtract this triangle, we can find this area, right? Like Suman, then students, Vaishnavi, Sangeeta. If you take the area of the quarter circle, you subtract the triangle, we can find this shaded area. Okay?
Yes, sir.
Yes.
Yeah, so that is what we should do. I suppose sides are 1. So what is this quarter circle? That is pi r square. This is the area of the entire circle divided by 4. Okay, and subtract the triangle's area. That is half into breadth into height. I suppose that is 1 by 2. Correct? Okay, correct. Now what we have here is only half of the shaded area. Notice this is symmetrical. If you look from this side or this side, this is symmetrical, right? We got 1/2. How do you find the total shaded area? You multiply that by
2.
2. So this is shaded area. Okay. So what is this non-shaded area? Take this value, subtract it from total area. Total area, can someone else answer? What is the total area here? Which is a square?
1.
Yeah. So that is just 1 minus shaded area. Fine. Now at least students who had trouble were able to solve this. Okay. Again, so couple of things. We'll try to make the class efficient. We'll try to address everyone, but at the same time, we'll also make sure the class is not boring for others in the class. So interrupt and ask me doubts. I will answer, but if there is like Inception movie, there's like a doubt within a doubt within a doubt. We'll usually deal with it at the end of the class. Okay, does that make sense?
Yes, sir.
Yes, sir.
Okay, so great. This question, I think most of you had trouble. First of all, notice, so this figure is symmetric and has like 6 arms. The arms are symmetrical. This is one arm, another arm, another arm, another arm, another arm at the top, and another arm at the bottom or at the back side. So if you count the number of surfaces in one arm, you can multiply it by 6 and get the answer. And the real trick is counting the surfaces in one arm. Okay. What you should do is number of surfaces. First thing, in the side view, count that. Then count the number of surfaces from a top view for a one arm. What do you mean by that? Let's do side view for this particular arm. What kind of a surface is this chunk over here? Is it a pyramid, triangle? What kind of a surface is this? Just this spot.
Pyramid.
Pyramid so if you view it from a different angle, it says it's a pyramid, or they are like short corners here in the surface. Look at this from the top view. Are there like sharp corners for it to be a pyramid or something like that?
No,
Triangle.
So what is the surface?
Triangle.
Triangle, or triangle is a 2D shape. A better word is cone. By looking at this and this together, we can say this is a cone. Right? I have to use two views. I can't answer with one view. By looking at this and this forming a 3D picture, I notice it's a cone. How many surfaces are here? One. It's a cone, right? Just one surface. How many surface does a sphere have? One. Right? Just like a cone, there is one. Okay. What kind of a, then we go to some other student. What kind of a surface do we have here? Is it like a cube? What kind of surface? Let's go to Kishore, Benarut, Bonu. Even Vivek, right?
I couldn't understand that cone part.
Sorry, Bono?
I couldn't understand that cone part. How we have got that cone, like triangle and
triangular cone. Okay, if you don't follow, we'll have to use 3D view modeler or something like that. Okay, why don't you do this as an exercise? Take a cone, try to draw it from two views, side view and top view. See how it should look. Compare that with a pyramid. Can you try that exercise? Take a pyramid, look at it from the top and from the side. Take a cone, look at it from the top and the side. And then can you get back to this?
Okay.
Yeah, try that. And yeah, cone is slightly a special case here, but let's go to this detail here. What kind of surface is this? Vivek, yeah, unable to hear.
Cuboid.
Cuboid. This is a cylinder. Again, if it's a cuboid, will there be like sharp corners here, or will it be a circle here? It's a circle, right?
Yeah.
From the top, and let's look like a square from this view. The only way that can happen is it's a cylinder. Again, how do I know? Compare a cuboid and a cylinder. Two different projections, you will realize it's a cylinder. So there is one more surface here. Okay. Okay, so these questions are taking longer than I anticipated, but we'll go through this. What is here is actually a cuboid. How do I know that? From the side it has, I can see one side, two side. So probably I notice this side and this side here. So this is, I see a side here, that is over here. Then I see a side here, that is over here. Then behind these two surfaces, there are like two more sides here and here. So combine this information with this information. What do we have here? At least any one student?
Cuboid.
Cuboid. This is a cuboid. In fact, we can compare and contrast a cylinder and a cone right here. Cylinder, cuboid, and a cone using these two information. So this is a cuboid, which means at least in the sides there are four. We'll come to this part, the top view part separately. We are only looking at things from the side and counting the surfaces. And finally, this chunk, give it some thought after the class. It's again, notice it's circular from top view. It looks like
Cylinder.
Yeah, this is a cylinder. Okay, so there is one surface. So how many surfaces from the side view for a given arm? 7. 1 plus 1 plus 4 plus 1. Agree? I just counted the number of surfaces here. Okay. Then who said yes? Akansha or Urvi?
I said yes, sir. Akansha.
Akansha. Okay. Then okay. Then now rest of the question will give chance to others. Now let's look at count the surfaces that are not in the sides but that are in the at these lines over here. That is, it's good to look at this view. Okay. Did we already count the cone? Did we count this surface that is showing up here? Benar, Banu.
Yes, sir, we have already counted only one surface.
Okay, so in the top, this surface is already counted. Is this surface counted? So it shows up as a line here. When viewed from the top, it's a square. Notice there is one more surface here. And this line over here shows up as this patch, this patch, this patch, and this patch. So we have one surface here, 2, 3, or to be consistent with how we are doing, 1, 1, 1, 1. So there are 5 surfaces in the top that we did not count. Okay. I can erase this to have the original view. Let me use a pointer. We already counted the cone. So there is this one surface here that looks like a square. Then there are 4 chunks here. 1, 2, 3, and 4. Those are 4 separate surfaces just connected by points. So 4 surfaces plus 5th surface here. Top has 5 surfaces. So how many surfaces does an arm have?
12.
12. So how many surfaces does the symmetric shape have?
6.
Okay, thanks, Jyoti. 6 into 12, right? 72. This is a very hard question. This is from spatial aptitude. Okay. it's fine, at least initially you don't get this, but this is a possible, this is actually a seed exam question, but is there in GATE syllabus. Okay, this one question I'll try to pick up pace from now on. First step regarding GATE exam time management. There will be one question in the aptitude part in the one logical detection question. Some set of information data are given. We have to detect, cases. Who is sitting next to whom? Who is, things like that. It could be like blood relations. Who is related to whom? And things like ages. Who is older? Who is younger? Questions like this. So these all are kind of logical questions. Two things about it. It's time consuming and it's tiring, mentally very tiring. Not like recall based questions, not like formula based questions. It's very, very tiring to see all these conditions and come up with a precise answer. So skip this question at the first pass, get back to it at the end of it. Seating arrangements, things like this, blood relations, puzzles, skip it at the first pass. Okay, first examination tip. If you sit here, you'll be spending 15 minutes just trying to solve this one question. In fact, already notice strategically we are making a mistake. We have been spending so much time in one hard question. We are already like close to, we have spent more than 45 minutes, right? So agree with this step. This will save you a lot of time. So start with this one tip right away. Let me solve this very quickly.
Yes, sir.
Here. Notice, okay, H plus G is greater than I plus S. That is the condition given here. The age difference between Geeta and Saira is 1 year. So Geeta's age minus Saira's age, the absolute difference is 1. And things are listed in order here. Note ones, age doesn't, not less than 3 years and all that. So nice conditions. Here, if I had to quickly solve this, rule out incorrect options and try to pick, options that are correct. Can I quickly rule out any incorrect options? What does this condition imply? Either GS should be there or SG should be there, so that the difference is 1. Agree? In this order, it should be either SG or GS should be there.
Yes.
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 Okay. Can this possibly be correct? It violates
No.
this condition. I just ruled it out. This is possible. This is possible. This is possible. Okay. At least I ruled out one out of 3. I won't get likely negative marks. I might as well pick things and move on. But use this condition. Here, so S is greater than let's start using, we can pick anywhere. Question is this condition satisfied by these 3 candidates over here? Does H plus G satisfy I plus S here? Yeah. H is greater than, or I is older, so I is greater than H, and S is older, so S is greater than G. Agree? So what is sum of I plus S? It should be greater than H plus G, right? In this order, I is older than H. Agree with this relation?
Yes, sir.
And again, S is older than G, so I plus S should be greater than H plus G. If you add larger values, the smaller value should be smaller, right? So this is not possible. And again, can we quickly eliminate any of this? I is greater than G and S is greater than H. Again, we violate this condition, right? Sum of I plus S is greater than G plus H. So what is our option here? So this question I answered by ruling out incorrect options. Okay, logic-based question. If you don't follow this, we'll get back to this later. This needs some practice. Even with practice, this is time-consuming and tiring. And let's get to easy questions. So this is a simple Venn diagram-based question. Okay, we have hockey players, we have football players, and then so these are players who play both hockey and football. Then of course there could be players who doesn't play neither hockey and football. So this is H, this is F, this chunk over here is H intersection F, and this chunk over here is S minus H union. Okay, so what is given? This is number of hockey players, H. This is number of football players. And what is 25? 25 is the sample set, this entire rectangle. And how many players play both of them? This is H intersection F, right? And this is 10. So can we quickly find out what is H union F? That is number of people here.
Yes, sir.
H plus F minus H intersection F. Okay, a couple of things. I'm going to not start things from scratch for this particular class because no, we haven't spent any time on this. But subsequent classes, we'll start with this basic relation, why that shows up and all that. But today we are not going to do that. So H is given to be 15, F is 17, H minus F is 10. Can someone quickly tell me what is H union F?
$22.
Okay, thank you. 22. So the answer that we are looking for is total minus H union F, that is 3. Okay. Prince Modi. Okay, the only detail here is the trick word here is growth. This is defined on percentages. You shouldn't look at what increases more, but with respect to the starting value is the percentage change higher. And based on that, which one has a higher percentage change? I think it's this, right? 75 to 115 is the highest, right? So percentage change would be 115 minus 75. There is a change. Percentage of that would be 75 into 100. This should be highest for this given data. So I think type 1 is correct. Anyone quickly verify that?
Yes, sir, type 1.
Correct. Okay. Yeah, very simple question, a data interpretation question. We shouldn't have issues here. So this is a slightly tricky text inference question. Okay. And many of the options seem to fit well. What we should be focusing on is what is the statement that best sums up this entire 3 sentences, not just 1 or 2 of that, but in general, what are they trying to say? Okay. Okay, this happens. Warfare has changed from this to suppression. Chemical agents, or seem to be suited. Regretfully is very, very important. This connecting word over here. People in military establishments think chemical agents are useful. So people in military establishments think. Okay, so people in military establishments like to use. We cannot generalize. Okay, slightly not a good idea. Chemical agents are useful in modern warfare. I think. Yeah. So, I mean, at least people think this is not correct. We'll get to the details later. Modern warfare has resulted in civil strife. I think, how about this option? It has resulted in suppression of civil population. Again, this is not correct. The best option over here is, this is happening and regretfully it's happening. So such a thing is undesirable. Okay, this is the best option. Okay, quickly, most of us have discussed this. Heart failure, pumping efficiency drops.
Sir, D.
In the previous question?
Sir, this one. Sir, this one. No, sir. Sir, after this. Yes,
No. That is what I am saying. This is like, say, heart is supposed to pump, human heart 80 ml doesn't pump 80 ml. It pumps 50 ml, 60 ml and all that. That is known as heart failure. Okay. So pumping efficiency drops, or heart kind of becomes weak. It's a muscle, right? The muscle doesn't it's not vigorous enough. That is heart failure. Heart attack and myocardial infarction are same. Essentially blockage of coronary arteries. Blockage of coronary arteries. There is a slight complication here, because blockage of coronary arteries can in turn trigger electrical problem. But let's say this is a VFib for now, ventricular fibrillation. That is, the ventricles beat extremely abnormally. Electrical activity in the ventricles of the heart are extremely abnormal. Ventricular fibrillation. So abnormal that the heart dies. Okay, so C is the best option. D is not. Okay, B and D are in fact correct. They are blockage of coronary arteries. Okay, anyone still thinks D is correct answer?
No, sir.
No. Okay, great.
No, sir.
Great. Which are the list of bones in the, okay. More
Sir,
than the, yes.
A.
Xiphoid process.
Yeah. Xiphoid process, again, we have to see, I'll just use my anatomy here. We have this sternum over here. This is, I think, called the manubrium, this bone over here. The tip here somewhere is known as the xiphoid process. So some of you thought process, it's not a bone and all that. No, anatomy, they use very obscure words. So this is a bone, but it's below xiphoid process. Cocci is the tail end of the spine. Okay.
Sir, manubrium is superior to xiphoid process.
Superior, yeah, that's correct. So this is the correct answer. A is correct. Okay, we have like the sternum over here, where this is the manubrium. The bottom part, this is xiphoid process. This is the manubrium.
Then A will be correct, no?
Yeah, A is correct.
Yes, A is only the
A is correct. Okay, femur somewhere in the leg. Okay, A is correct. Okay, this question is, tricky. We need to know how to solve Thevenin's equivalent resistance. I briefly discussed that in the mock test. What I will do now is just to say, we'll just write down this resistance. What is parallel to what in the
R1 parallel R4, R2 parallel R3.
Okay, we have one answer, R1 parallel R4, and then R3 parallel R2. And how do these two combinations work in the Thevenin equivalent resistance?
Thevenin is equivalent.
They are in series, right?
Yes.
Is there anyone who thinks the other way around? Let's say R3 parallel R4.
Sir, R3 parallel R2 in series, and R4 parallel R1.
Okay, so all of you agree with what I have written here? Anyone who doesn't agree? Anyone thinks instead of R1 R4 parallel, it's R3 R4 parallel?
Sir, R1 is parallel to R2 and R3 is parallel to R4, because in parallel voltage will be same. So plus 10 volt, it is.
No.
No, R1
No.
parallel R4 is right, sir.
Yeah. That is fine. Let's have a discussion. The thing is, we should know where we start and where we end. Is this point different from this point in the equivalent resistance? In fact, let me just draw that.
Sir, if we will take Rg is equal to 0, then the point above R3 and below R3 will be the same. So R3 parallel to R2 is
R3,
right.
Okay. Okay. This is why I said we need a lot of theory here. Rg is not 0. Rg is infinity. We just remove that. Okay. Remove the load. No connection here. This is the equivalent Thevenin circuit for finding the resistance. Based on the circuit, tell me, is this correct or not? At least those who said, claimed otherwise, based on this circuit, do you agree with this statement? How about these two voltages? Are these two at the same voltage or a different voltage?
Different, sir.
Come on, I have just connected it using a wire, which is supposed to be
Same voltage.
same voltage.
Same.
Notice, yeah, that is a very tricky thing. In the equivalent circuit, this point is in same voltage as this point, which means they are short circuited, right? Instead of drawing this here, can I just draw it over here to make things easier?
Yes, sir.
Right? No, let me remove that. Do you see these 2 points are same? So if I start here and go till this point, is R3 parallel to R2, or like R2 parallel to R1?
R1 parallel R2 and R3 parallel R4.
Okay.
No, sir. R3
Yeah,
parallel R2, R4 parallel.
No. Okay. Again, let me redraw this for your simplification. Okay. We start here. We have R3, and it goes to 1 point. So I'm going to draw that here. So it came to 1 point, and then again there is this. Pardon my sketching. Sketching in this particular row. There is R4, R1, and then there are wires. There is R3, R2. So R3 and R2 are parallel, or R2 and R1 are parallel. So notice all these points are same potential. So I just move them across.
R3 and R2 are parallel.
Yeah. So what we have here is correct. Okay. So why is this the Thevenin's equivalence resistance? Then of course we have to go ahead and solve this problem. We'll come to that later. But for now, at least do we all agree with this step?
Yes, sir.
Okay. Is there anyone who doesn't agree? Great. Okay. But anyways, this problem, I have given the solution. At least based on this discussion, try to go back, look at the solution again and see. Else we'll look at the theory, better when we deal with theoretical circuits. Okay. This is a very easy problem. All you need to know is elastic modulus, also known as Young's modulus many times. This is just stress by strain. Can you find stress and strain from the given information? What is given is dimension. Yeah. What is given is dimensions. So this cross section dimensions are given, so we can find area. And stress is nothing but force by area. Okay. And what is strain? Change in length per original length. Okay. I think change in length is given. Original length is given between the 2 points. Force is given. And the cross sections are given to find area. So we can calculate this expression. To make it more explicit, this is normalized force per unit area, that is stress. Again, this is known as stress, and this is known as strain, and this is delta L by L. Okay. Plug in the numbers with proper units, and you should get it. Okay. So convert everything to meters, convert everything to standard units, convert millimeters to meters, and we should get the answer properly. Anyone has questions here? We implementing this and all that will come later. You also need to some practice with the gate calculator. But any question here with this? Okay. If things are silent, I'm going to presume we know.
No, sir.
Okay. Great. This is I think just a theory-based question. The real key thing here is to notice there is something called DTFT and there is something called DFT. Okay, discrete Fourier transform and discrete time Fourier transform. But other than this, it's a straightforward question. So FFT is for DTFT or DFT? DFT, right? Discrete Fourier transform, right? Is it a discrete time Fourier transform or is it discrete Fourier transform? Can someone quickly answer between these two?
DFT.
DFT.
DFT, great. Okay, DFT, this is correct. I think these statements of QDTK is common algorithms. Okay, these are fact and recall based. But at this stage, I just want you to know there are two different things here. Okay, so what is the normal breathing rate?
16 to 20 beats per minute.
12 to 16 breaths per minute.
Yeah, let's say approximately 15 breaths per minute. Notice this corresponds to 15 by 60, breaths per second. That is 15 by 60 hertz per second, or approximately 0.25. So in the frequency axis, the respiration data here in 0.25, in and around that, and cardiac signals are like very, very high. The signal is there within 1 second. All that PQRST shows up within 1 second, so you need very high frequency to represent that. So it's like, at least let's say it's from 1 to 100, 150. So in this range, even 100, 250 also we can have signals. We have the cardiac signal in this range. Cardiac, I mean ECG, and respiratory is much lower than that. We have it here. How do we spread this? We allow only things in this range. So we do a high pass with a cutoff, somewhere over here, 0.5. Okay, certainly, sorry, it's a low pass, it's a high pass. It's between these two options. 49 is somewhere over here. Why use that as a cutoff? Use 0.5 as a cutoff, which is between 1 and 0.25. Okay. Okay, the answer here is esophagus. Why is C the answer? Can someone explain me give a physiological perspective or a functional perspective on why esophagus doesn't secrete any enzyme?
Esophagus is located in our trachea.
Yeah, okay, but
so
Sir,
It just transmits food in the mouth.
sir, esophagus is posterior to our trachea and it does not contain any enzyme secreting glands.
Why? The question is why? Okay, why?
The food, like mouth we chew and the stomach, there are acids to balance.
Okay,
the anatomy part, if you consider it.
Hold on. We'll give everyone a chance. Okay, I think I heard a good answer from Megha. Banu, you want to give it a shot?
The esophagus is like the others are the organs, and the esophagus is the part of it's like tube, the tube part.
Okay,
so,
again,
esophagus is a part of our respiratory system.
No. Esophagus is not respiratory system at all.
Sir, it is a part of
elementary canal.
Sir, it is not a part of respiratory system.
Yeah, not a part.
Contraction and relaxation occurs in esophagus to pass the food. That's why there is,
Yeah, Jyoti. Yeah, I think, see, all of us kind of like, we know, we are starting to get away, not just a recall based thing. See, in all this, so all these are parts of alimentary canal, that is the food tract. Food is supposed to stay in all these places. You are supposed to chew food will stay there for some time. Okay, so there is some enzyme to start digesting it. Stomach, of course, we know food stays there and get digested. Same with duodenum, but this is just a passage. Food doesn't stay there. It's just kind of. Of course, it's muscular and it passes food down. Food doesn't stay in esophagus, so there is no time to digest, secrete an enzyme and digest it. See that aspect, physiological aspect, no time to actually secrete something and digest the food.
Sir, may I tell one other reason?
Yes, please. Yes, Shubham.
Sir, esophagus contains mucus secreting glands, and mucus is not an enzyme.
Mucus secreting, yeah, this is to filter out things, partly there, but the idea is functionally food is not supposed to stay there. Okay. Simple physiological explanation. Okay, we'll try to get into more interesting physiological aspects later in the class, but yeah, very, very minor detail. Okay, so of course the answer here is esophagus. This is formula based. I'm not going to really, solve that. And to be honest, I don't remember that formula right now. I don't. I try to keep memory, use the brain for a nice discussion. So I try to keep formulas in a paper, somewhere else. Can all of you solve this? The solution is there, right there in YouTube, right?
Yes, sir.
Yes, sir.
Okay, yeah, please do that, because as I said, we can make use of this class more efficiently and productively. This is a very hard question. Interestingly, this is one question I am not able to find a shortcut answer till now. Reasonably short answer, 5-10 minute answer, but I'm not very happy with it. But essentially, whatever is given there in gate, I have given it here. B and C are correct. Y over damped, Y second order low pass filter. I discussed in 2021 solutions. Only minor detail, it's a multiple select question. You have to choose all correct options, even if it means some of them are repeating. Unlikely in gate, but technically we should also choose D to get marks here. Fine. Okay.
Yes.
Okay. And in fact, just many great questions. Again, let me get to the tips aspect of this. We don't have to know, the underlying theory many a times to answer gate questions. There are like about 5 questions like that in the whole gate paper. Do you believe that? So you have like 5 to 10 marks in the paper which you can answer without knowing underlying theory. You think it's possible?
सर इक्वेशन में सिर्फ वैल्यू पुट करनी है.
Yeah, many times
Might be
such questions are there. If they haven't given the equations, likely exponential. Guess and go on, okay? But many times they give the equation, they give everything. They just want you to put numbers and actually, put numbers with the proper units and give the answer. This is very common in aptitude. We don't know history. We don't read newspapers, but we don't know the market data they are talking about. But we can answer aptitude questions, right? Same thing also applies with core biomedical questions. Core biomedical, I mean, in biomedical as well as non-biomedical subjects. Example is here. We don't need to know biomaterials. We don't need to know biodegradable suture and all that, because everything is given right here. All you have to do is, okay, first time I read, biodegradable suture, I did not read it. I decided to skip it. So, okay, pass this question, move on, answer all the questions you know. Then you'll have time left. Then get back to this question. Try to read it at least once. And I think all of you here by now would have noticed, if you have read at least once, everything is given. What we want here is sigma naught. This is sigma. This is T. So this is ideally sigma of T, okay, to make things more clear. At a particular time, sigma value is given. And the characteristic time A is given. And then B is also given. So this is given, this is given, this is given, this is given. All you have to find is sigma. Simple calculation. Okay, this is a mistake that we don't want you to be doing. Mock test, admission test, of course, it makes sense. But simple things like this, these are what I would consider as unforced errors. We should start correcting. Okay, so next time you give the exam, you will be like careful about these questions.
Yes, sir.
Yes, sir.
Okay, and actually to test this, I'm going to give a slightly harder question that looks very, very new, but it's very easy. Okay, I have one more question in the paper. Okay, consider type 1 PDT. Did anyone figure out why the answer is 2? The answer is 2. Did anyone figure this one out why it's 2? Can someone explain?
We assume the transfer function to be.
Because, sir,
Will Swarnim the first and then Nandini.
Sir, I assume that it's a type 1 unity feedback system. So I assume the transfer function GS to be K by S. So now if I try to find the BC gain has to be found. So if I now calculate the magnitude, so in dB it would be 20 log k minus 20 log omega.
Okay.
So at omega equal to 2, it is given that the magnitude is 0. So I put 0. So from there I'll get the DC gain k, and we know kV is equal to SGS. So S and S will get cancelled. So when I put S equal to 0 as the limit, I will get 2.
Okay, great. So that's a theory underlying this question, but I'm going to make this slightly easier because we don't know, we haven't discussed what a type 1 system is. We don't know what a unity feedback system is. I'm not going to presume any of those things. We'll of course, as I said, we'll start from scratch. But for this question, he explained the underlying theory, but I'll make things very, very easy for you. There are some things called type 0, type 1, type 2 systems. Essentially, in the transfer function, the power of S in the denominator will specify whether it's we have g of s transfer function, and this will have some terms in the numerator, this will have some terms in the denominator, and there could be some powers of n, s power n like that. So if s power n is 0, okay, it's a type 0 system. If n is 1, it's a type 1 system, and n is 2, it's a type 2 system. Okay, very, very simply, the power of this s determines whether it's type 0, type 1, and type 2. And for this system, okay, the graph is going to look something like this. Perhaps it can go up and down here, doesn't matter, but this value will be 20 log of kt, that is position error. Okay, p for position. So wherever it touches the y-axis in the Bode plot, what a Bode plot, again we'll get to that, but let's presume we are talking about a Bode plot. Wherever it touches this y-axis, when frequency is 0, that is 20 log k position error. Then type 1 system, interestingly, this point doesn't tell us anything. It can go like this. Of course, after some time, it can go up, down, many things. But if you have to extend this initial line, okay, if you have to extend this initial line, wherever it touches here, that is going to be the velocity position constant, or this velocity error constant. And not velocity position constant, it's the velocity error constant, kb, that is asked in this question. And this will have a specific slope, 20 decibels per decade and all that. Type 2 system will have a much steeper slope. So compared to this, it's going to be much steeper, specifically 40 decibels per second. And after some time, it can start go many ways based on the terms over here. But if we again extend the initial line, where it touches here, this omega here will be root of Ka. So this was GATE 2021 question. This is the question I asked. So now based on this, do you see if it touches the 0 dB, so this is 0 decibels in this y-axis, this line is 0 decibels, wherever it touches, this is K, the frequency is K. At least based on these three figures you follow, answer is 2. So this was GATE 2021. And this is the mock. Based on this,
so it means for all three diagrams, type 0, type 1, type 2, it would be the point where it touches the x-axis, the 0 dB range would be the same as 2.
can you repeat that again? I couldn't hear you. Can you type that in the chat quickly? Okay, but the only detail is, of course, why the type 0 looks like this, why it is this value over here, why a type 1 looks like this, why this particular value. That is the theory aspect of it. We'll cover it in the class. But for now, these three systems, this is how the Bode plot should look. And for type 1 system, this value will directly give us K. And even what is KB, what is KA, what is KP, even those details we'll look at during the. Okay, for all three plots, the intersection with 0 dB line is 2, irrespective of frequency. No. See, here the initial line doesn't intersect 0 dB at all. If you extend this, the initial thing doesn't intersect at all. Okay, here this, if you extend this, these two cases only it intersects 0 dB. This case doesn't intersect the 0 dB at all. Okay, so the intersection of 0 dB line is 2, irrespective of frequency. No. So here in this case, type 1 for this particular example, if this given this value happens to be 2. It could have been 4, 6, any other value, any other radians per second. This example, this value turns out to be 2. So this is omega. This is frequency axis.
Okay. If the frequency is not, sorry for extending, but yeah, if the frequency is not 2 radians per second, it would be the same. Or how it changes, like how to calculate at that time.
Oh, how to characterize it? Okay, so see, now it is 2. For a type 2 system, Ka is 4. Okay, for a, we can't say this from type 0 system. We can't answer this, but for we can answer this and this.
The frequency 2 radians per second, it will be the same, sir. For anything.
Yeah, I'm slightly unable to hear you. Can we get back to it at the end of the class? Yeah. Somehow the voice is, very. I couldn't like quickly follow you. We'll get back to it. No need to find sorry. We will get back to this at the end of the class. This is for everyone. Okay, where are we? Quick check. Computer is getting slow. We use 1 hour. 5:30, 6:40, close on 1 hour 20 minutes. Where are we? We are at question 23. Reasonably okay. This is a basic theory-based question. Okay, we'll get to this.
Beer's law absorbs of light. Nernst equation is electrochemical cell.
Yeah, Nernst is electrochemical. Beer's
law is absorption of light.
Yeah. So
and R is thermo EMF.
Yeah, that is correct. In fact, yeah, basic match the following question, but we'll go into what is Beer's law, not Bragg's law, but Beer's law, Peltier, Nernst. We'll go deeper into it. I suppose all of you could answer this. Transfer function for a standard second order system, the standard form, we all should know. This is zeta. We have omega n s plus omega n square, and so this is the standard form. Compare with this and find the values. And critically damped, zeta is 1. Under damped, zeta will be less than 1. And over damped, zeta is greater than 1. But there is one more thing: if zeta is 0, it's undamped. Okay. How do you find 0? For example, for P, omega n is root 15, because omega n square is 15, omega n is root 15. And so 2 into zeta into root 15 is 5. So from this we can find zeta. Right? Very, very basic question. Okay, ultrasound question. What is intensity transmission coefficient? There is, there is at least one question from this topic. And this is actually a slightly harder question if they give it at an angle. I'll show the derivation. I'll show what these terms mean and all that. But for now, I have given the formula in the 2021 solutions. Take a look at it, plug in the values correctly, and you should get this. Usually I had, I think, a slight error in the key. Answer is very close to 1. Okay.
Okay.
Okay. Root mean square. What is the RMS value?
It's a 0.996.
Okay. Yeah. 0.99. Usually, rounded off to 2 decimal places, there is like 1% leeway, even 5% leeway here and there. 1.99. All those are correct. Okay. What is RMS value? Okay, RMS, can we at least write the abbreviation in the chat? What is R, what is M, what is S?
Root mean square.
Thanks. So we have, thank you, it's root mean square. We have a root. We take the root of some kind of mean. So we divide it by the number of terms and we take the mean of the square. So this is x1 square plus x2 square plus xn square, right? So just, this is root mean square, and find it for this given values, you can get the answer. Okay, and of course the real trick is what is root mean square, what is standard deviation, what is variance, what is root mean squared error, couple of basic statistic related terms over here. That is what we are supposed to do. Okay, this question, let's try to spend some time. We all know A is correct. All of you agree this is an MSQ. Reynolds number is just, it's a non-dimensional number. First of all, this is non-dimensional. What do we mean by non-dimensional? Can someone answer?
Sir, I didn't get the previous one.
Man, so this is RMS. So just do root of how many n? What is the value of n? 1, 2, 3, 4, 5. So 1 by 5. 25 square. Have answer is in nanovolts, so keep things everything in nanovolts plus.
Okay, sir.
56 square plus 33 square plus 10 square plus 62 square. Okay.
Okay.
Okay. Real question is okay. So we're not going into what is non-dimensional and all that. What is the Reynolds number used for? At least can we have any comments on that? What is the Reynolds number? What is it used for?
It doesn't have any unit.
Yeah, it doesn't have any unit.
Reynolds number.
Okay.
Flow measurement.
Yeah. So this number will actually tell you what kind of flow, how is, at least within an aortic flow, how is blood going to flow? Whether flow will be very, very nice. One term for that is pulsatile, laminar. Okay. Whether flow will be laminar, or whether flow will be turbulent. Okay. Turbulent, can you all like quickly associate what turbulent is? Like flow is like, we all can relate with that, right?
Flow will be turbulent, sir.
Yeah. Based on Reynolds number, we can categorize whether flow is turbulent, whether flow is laminar, whether in between the two cases and all that. So this number is useful for that. And okay, for now we'll stop here. And Reynolds number is, it's a non-dimensional number, doesn't have any units, doesn't have any dimensions. It's given by rho VD by mu. Okay, rho, then V, mu. All this, what is explained here? Okay, if any of you don't follow things here except for perhaps kinematic viscosity and dynamic viscosity, rest of the things, get back to me after the class. So let's say this equation is correct. Can we also say which of the other options are correct? This is option B correct? Why is B correct?
Density of the
Because the
fluid.
kinematic viscosity is equal to dynamic viscosity upon density.
Yeah, this mu is not just mu over rho. So mu over rho is mu. So this is correct. Okay. Okay. It boils down to what is kinematic viscosity. It's kind of some kind of a normalized viscosity, normalized using density. Okay. Okay. So this is correct. Is C correct? So can we somehow move from notice from?
Sir, all are correct because Reynolds number directly proportional to diameter.
No. That is not the way to answer it. So if I write, put a constant here, is that correct? If I put 100 here, it's proportional diameter. Is it correct?
No, sir.
Yeah. That's not the reason.
We'll have to do dimensional analysis.
We have to do dimensional analysis, and we have to make sure all this So even in this form, the units cancel. In this form, units cancel. The thing is, there is a relationship between mean velocity, average flow rate, and the cross-section area. In fact, the mean velocity is just take the average flow divided by the cross-section area. That should give the mean velocity, B. Okay, so just use that relation, you should get C. And of course, if you use that relation from A, you should get B. Okay. Why this is the case? Again, you check the dimensions of what is flow rate, try to write the units of this, and then see if you get the units of velocity, and then we'll go explain why this relation holds good. This is definition, that is kinematic viscosity is defined like this. This is a very basic relation that we can check.
Sir, D is also right then.
Yeah, D is also right. A, B, C, D, all or 4 are correct. Only then marks. Okay. Okay, but in class, first of all, I have put videos on biofluid mechanics. Take a look at that. Just 8 videos or something like that for 10 minutes. I'll explain what is Reynolds number, how we get this form, perhaps at least how to make sense of this form, many of these relations and all that. But we'll look at them in class. Okay. There is something called the most beautiful equation in mathematics. E power I pi is
It's a Euler's equation.
Yeah,
1.
1. And why is this beautiful? Like the formula, right? Why is it beautiful? So, and to be consistent, the I here, this is essentially, I call it J because of the terminology we use. So e power J pi is 1. So J is a complex number. We don't know what actually a complex number is. Pi is some kind of irrational number. Okay, and what kind of a E number is E? So E is again a very, very peculiar number. Okay, go take a look at it. Somehow you take power of E power J pi, you get this nice number 1. Almost like, take donkeys, power it with something, you end up with a nice
Sir,
behavior.
Sir, but cos 180 is -1. Sir, then -1 should come here.
Where? Where? Here or here? Cos pi is -1.
Sir, e to the power j pi equal to -1 because cos 180 is -1.
Okay. Cos pi is -1, is it?
Yes, sir.
Okay, what is e power minus j pi?
Then also it will be -1.
Oh, okay. I see where the thing is. So I should have written. Does this make sense?
0.
Okay.
Yes, sir.
I just brought that -1. Yeah, thanks. That's correct. E power cos pi. I mean, j pi is cos pi, which is -1. So, okay, this is the relation. Okay. Yeah, connect some, vaguely unrelated numbers. Supposed to be one of the beautiful relations in mathematics. Thanks for helping me correct it. By the way, supposed to be one of the beautiful relations. So now 0 also showed up here. And the reason to pull this up right now was one of the fundamental identities in complex number, e power j theta is cos theta plus j sin theta. Okay, this is cos theta, this is sin theta. I've written as c theta minus theta. And that makes this 0 to pi by 2 e power jx by e power minus jx dx. And so this is just 0 to pi by 2 e power 2jx dx. So can you all quickly do this integral right now? It's e power 2jx
2jx upon
by 2j, right, from 0 to pi by 2. Okay, so I can take this j to the top, it becomes minus j by 2. So what is e power j pi? We just had that answer, right? Someone said it's -1. Correct? and then e power 0, that's 1. So 2 times minus j, we get j. Okay. I did this because many of you had confusions with the minus j. All of you agree here?
Yes, sir.
Yes, sir.
Yes, sir.
Great. But remember, very, very fundamental relation. This question as such looks, some cos, some j. Okay, even if you try to multiply it by complex conjugates, that is cos x plus j sin x by cos x minus j sin x into the conjugate of the denominator, that will be cos x plus j sin x by cos x plus j sin x. Okay, so
Then it
notice,
will become lengthy, sir.
no, it doesn't become lengthy. Hold on. So let me write it over here. What is this term? Cx plus j sin x square. What is that? E power j2x. Agree?
Yes.
Okay. And what is the product of denominators?
Cos square x minus j square sin square x.
What is minus j square?
Minus j square is 1.
Minus j square is
J square
1.
is -1, so minus j square
Yeah.
is
So what we have is cos square x plus sin square x. So what is this?
1.
Okay. Notice we have square of this, which is just e power j2x. Okay. Just because
Yes.
this is e power jx, power that e power j2x. So again, a gate question exploiting this basic identity. This is very, 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 very important. Okay. And question looks hard. Don't give away. Most gate questions answer is like one step down the road. Okay. Scanning electron microscopy. So this is taken by transmission electron microscopy. You can't see any three-dimensional details. Only like flat surface. You can't say whether it's like going in or coming out. I think this is wrong. Images of polio virus. Okay. I don't know if it's like I can't. I only have 2D information. That is transmission electron. This is spectrum, likely FTIR.
Sir,
uh-huh.
this one, the last one, it is.
Yeah, this is the correct answer. This is you start seeing the surface details, the morphology details, which can be seen in scanning electron microscopy. And any kind of this kind of symmetry here, that is diffraction. Okay, XRT. And so this is of course our SE, because I can see surface details. Most of you got this correct. Okay, this is pretty much directly the gate question. First thing, so let's again, let me ask this question again. Was the mock test very different from gate 2021? Very similar, or at least similar?
Yes, sir, similar.
Okay, interesting point. All the questions in this mock test were, not all, okay, most of the questions in this mock test were essentially given during practice tests. So pointers, the practice tests I gave pretty much had many of the actual gate questions. Very similar to that. And this question, they didn't even change the numbers. I took it from Prince and Link's example. They also did the same thing. Without changing numbers, they gave the question. Okay. So first thing, so all the questions are essentially I'm using from previous year's papers. Now don't try to get those papers and try to score high in subsequent mock tests. But the point is, we spend some time setting it up. But let's get here. Essentially, the gate question. Only detail here is Al per equivalence, that is known as aluminum equivalence. Instead of aluminum, if we are to use copper, what is the thickness? The term for that is aluminum equivalence. Okay, that is all this given, and you know how to solve this, right?
Yes, sir.
Yeah, it comes from e power mu 1 z1 should be same as e power mu 2 z2, take ln and all that, then you'll end up with this relation mu1 z1 is mu2 z2, and then mu here is product of this mass attenuation coefficients. Okay, some terminology is very straightforward and solved. Okay. Okay, let's spend some time on this question. Okay, now how many of you still say the answer is 0? How many of you got the answer that I had? A critical, we need some space for this, so let me try to outline things a bit. Gate exam question was this. So I said solution, any function of the form f of x minus ct is a solution where, c here is phi. Is there a difference between this equation and this equation? Again, many of you know the answer.
Same, sir.
First term it is a
No,
function
sir.
of and second term it's function of b.
Yeah, notice that difference. So the coefficient here is 1, or even if it is not 1, make it 1 and that is the wave speed. Okay. So for example, have the question been 2 times 10, make this coefficient 1 by dividing by 2. Then this becomes 1 and this becomes 5. So wave speed is coefficient of this term. Okay. And interestingly, we have the orders reverse. So we have to find the coefficient of this term, making this coefficient 1. So divide the whole thing by 5. This time, this side is 0, doesn't matter. So these two cancel, and the wave speed here is 1 over 5. So based on that, the answer here should be sine of x minus 1 by 5 t, and x is given, t is given. If you find the value for this, I think you should get the answer that I have. So this is 5 minus 6 pi by 23. Fine. All of you agree. The point of this question is gate will keep time and again will set traps, checking for minor details like this. This is a typical gate trap. So again, so letters matter, whether, minor details, even letters matter. Minor change in the question at a letter level can drastically change the answer. And gate keeps on playing around with this. This is a nice example. So, okay, calculate this, but why is this the answer? So, can someone explain why this is the answer?
Transport equation.
Yeah, transport
Sir, it
equation.
is a property of transport equation.
Property of transport equation. Great. That is great. And what does that property actually mean? So what is f of x minus ct? So what is the difference between, say, f of x and f of x minus, say, x minus t? What is the difference between these two? If t is some function, let's even call this, x minus 1. What is the difference between these two? If I had, yeah, this is just a shifted function of this original thing. So transport equation, we say things are not going to shift. Whatever the initial function, that will keep shifting. Okay, that is the physical meaning of this, and this is the property. And final question, can someone say how this, can you show it's a property of this equation? How would you go by checking, verifying, or showing that this is a property of this particular transport equation? What would be your approach? Okay, so what I am going to do is call this x minus ct as one variable. Why do I do that? It will become evident in a minute. So I'm going to, instead of y, I'm going to substitute this function. So I want to know what is dou f of x minus ct. I'm going to call it one variable by dou t. Okay, plus c times dou this function of x minus ct, that is f of u by dou x. I want to find this. How do I take partial derivative of this function which is of a different variable? What mathematical rule applies here? If I write the answer, you'll all like, oh yeah, I know this.
Chain rule or differentiation?
Huh?
Chain rule?
Okay, thank you. 1 second, I missed that. Where is our participants list? Who is that again?
It's me, Sean.
Oh, thanks for me. Yeah. There is this rule called chain rule. All it says is, no, this is nothing but dou f by, first take the derivative of u, and then to make up for this, do dou u by dou t. Okay, so this term is essentially this using chain rule. And what is this term? Dou f by dou u into dou u by dou x. Can we know? So there is a dou f by dou u common term. Do you know dou u by dou t? What is u? Can we take partial derivative of u? U is x minus ct. Can I find dou u by dou t?
Minus c.
Minus c. Okay, so this is minus c. What is dou u by dou x?
1.
1.
1. So there is a, no, suddenly there is a minus c appeared here, dou f by dou u plus c dou f by dou u. What happens to the sum? Do it in a paper. You could do it. Just if dou f by dou u is common, we have a minus c here and a plus c here. Cancels, becomes 0.
0.
So notice any function of the form f of u, where u is x minus ct, will give 0 for this. Take this equation, you plug in any function of the form f x minus ct, you will get 0 in the RHS, which is what we mean by this is a property of this equation. And physically, it means things just, there is a time shift between the function. The function moves over time. Fine?
Yes, sir.
Yes, sir.
Yeah, so there is an application aspect of it, there is a physical interpretation aspect of it, and the actual property derivation in many cases is 1 or 2 lines. Okay. Okay. Doppler shift, flow, frequency, this thing. You have to memorize many formulas. We'll try to give a list, but start memorizing, start writing your own notes. The penalty I pay is I also have to memorize some of these formulas. I think change in frequency is 2v by c cos theta, the Doppler frequency. Interestingly, fd is not given, so we have to infer fd from some other information. So we are given the wavelength, and anything else is given here. Also, yeah, some other information we'll have to infer, usually fd times lambda, this should be c, right? Take one wavelength, multiply that by frequency, that is the distance it has moved in 1 second. So we also know FD. This can be replaced with the. So I'm going to write it. This is different C. This is CW by lambda. We have to recall CW. This is speed of ultrasound in normal tissue or in blood, approximately 1500. Does these two C's cancel each other, by the way?
Yes, sir.
Oh, this is also CW. Yeah, this is also speed of the same thing. So yeah, something cancels. So we know V velocity, we know cos theta, we know the angle, and then lambda is given. Okay.
Sir, the numerator, see, it is the average flow velocity, right? The denominator is
No, average flow velocity is B.
meter per.
This is B.
Okay.
Okay, and is this formula correct, by the way? Anyone? My memory
Correct,
is
sir.
correct, right? Yeah, velocity by wavelength, I suppose we get frequency. Okay. Yeah, see, this is flow velocity. The CW is speed of that ultrasound or this light, whatever they are using in the medium. Okay. Okay. Yeah, you'll have to, in fact, you don't have to recall this. There are questions where you'll have to recall this, but remember this value. Usually the speed is, this case it's actually laser light, so 3 into 10 power 8, but ultrasound it should be 1500. In this question, they cancel and doesn't matter. I was wondering how many of you are getting proper answer for this. Now I see that the speeds cancel out each other. Okay. Yeah, I have been having many meetings since the morning, so I'm slightly getting tired. Also starting this class after a long time. So yet to pick up my stamina and get used to this. So yeah, this is actually ultrasound laser. If any of you are still with me, the actual speed you are supposed to use here might be speed of light. Okay, we'll get to that later. Okay, following information is given for a linear system. X1, X2, X3, Y1, Y2, Y3. Output of the system is this. How do we solve this? Any strategies? Would we Sparnindu, can one of you help me? Given like our hot hitters.
So we have to represent xt in terms of x1, x2, x3 somehow.
Yeah, that's all we have to do. Notice that we have to represent this x of t using some combination of this thing. Notice first there is a 3 sin t, so there is like actually a 3x2. That 3x2 comes up with an additional cos t. Okay, so we'll have to make up for
As a subtract x1.
Yeah, we'll subtract it using x1. And then of course we have half of x3. Half of x3. So this is a linear system. So if you can add inputs, the outputs add up. So the outputs add up in the ratio of these coefficients. So minus 3, 3.5. Okay. So multiply and add up and you'll get the answer here. In fact, some of you did something very, very tricky. Notice there is like sin 3t and all won't show up. So this option is ruled out. This option is ruled out. Then it's between B and D. Go pick one. I think B is the correct answer to do the output summation properly. Right? B is the correct answer, right?
Yes, sir.
3y2 minus 3y1 plus half y3. Notice of this, you could actually eliminate two options without just recognizing it's a linear system, not do any complicated math. Here it's actually not complicated. Things easily cancel. Yeah, do it properly, you get B. Even otherwise, eliminate A and C. Fluke, however you call it. So now different states are calling this guessing differently. However you call it, between B and T, B and option D, pick one and move on. Okay, voltage across an inductor. I discussed this with pretty much everyone. This is L di by dt, and I as a function of time is given. So the slope here is di by dt. Slope here is essentially minus 1. Okay, this is di by dt at time point 1.5. So the answer is minus 1 times 2. Some of you had issues with this problem, so let me fully do this. All we need to know is, interestingly, I had given this question in a mock test. Same thing came in GATE 2021. So we have f, gradient of f, dou f by dou x I, dou f by dou y j. So it's 2xi plus 6y j. Okay, and we also want the normal to this direction, normal to this circle. Normal to the circle is very, very simple. Normal direction, just again take gradient. So that will be 2xi plus 2yj. So the magnitude of directional derivative along the direction, just gradient of f dot n. Is that correct?
Sir, del f dot n equal to 1, we should put.
Del f dot n equal to 1, or a better way to put it is, to get the magnitude, we should dot it with a unit vector. If it's a normal vector, it better be unit. What do we mean by that? What is the value of this, magnitude of this? 2 into x square plus y square, or root of x square plus y square. We should normalize that. So we should find a unit vector, which I'm going to denote with a hat. By this symbol, I mean a vector, and by putting a hat, I mean it's unit. Normalize it, just do x I by y j. The 2 will disappear as you normalize. There will be this x square plus y square. So this is not the magnitude of the directional derivative. What we want is del f dotted with this unit vector. Now this is normalized. Check its magnitude. It should be 1. So dot it with that. Okay, that should be 2x square plus 6y square by x square plus y square, and evaluate this at 1, 1. I think this is 8 by root 2. So multiply and divide by root 2. Sounds good? So be careful. You should dot it with a unit vector. Simple thing. You take the gradient, dot it with I, you get the partial derivative with respect to x. So you always dot it with a unit vector. For example, if you dot it along I direction, you get the partial derivative along x. You dot it along this unit vector, you get the magnitude of change along that direction. This is magnitude of change along I direction. Great. Smooth muscles, striated, anatomy question. Non-striated involuntary uninucleate. Is D correct? Can someone help me here? Do you know? Did you find the answer here? D is correct, right?
Yes, sir.
Anatomy, we can always verify
Yes, sir.
that. This is directly from K-on. Notice smooth muscle cells. There were questions from 2020. There was a question from bone microstructure, question from muscle microstructure, smooth muscle cell microstructure. So this microstructure based anatomy questions seem to show, at least for the past 2 years, this has showed up. Okay, just a pointer. Okay, microscopically, muscle fiber contains parallel myofibrils. Yeah, again, another, I gave a microstructure based question. We will see what a sarcomere, myosin, myofilament, all that. In fact, we'll go one step further. We'll also look at this actin myosin dynamics and all that. For now, the answer here is, I think, the sarcomere. Yeah, this I think is a sarcomere. Okay, we'll look at the figure. We'll also we'll animate the figure, or we'll look at the physiology of this. This is important. I want to spend some time here. I think we have 1 more hour left. We can solve 25 questions. That's fine. But let's let's spend 10 to 15 minutes here. Again, this is some question that I discussed with most of you. So first order system, you know, it goes and saturates. It's an exponential decay kind of thing. And with a couple of constants, you can make it a saturation kind of thing or a decay kind of thing. Okay. In this case, essentially, you know, it starts from 0, rises exponentially. It kind of saturates, supposed to saturate at a value. So this is how the actual function looks. This is t. This is y of t. Okay, and we are what we are given is some time points. If we actually plot it, it will look like a curve like this. Okay, and YSS, notice this asymptotic value is just YSS. It stands for steady state. Okay, essentially after some time things are not going to change. That steady state function is YSS. Notice y doesn't change after some time. So YSS is 2.28. Okay, and the way this is written, this is simple. U of t, it says there is nothing in this function, you know, less than 0. Function has values only after for positive t. That's what this U of t says. So you can pretty much remove this U of t, unit step function. There is a constant part and there is a decaying part. Okay, and based on the sign of k, it will look like this or it will look like this. Can you find this k somehow? Yes, use a special case here. Notice 0 is YSS plus k e power minus t by 2. What is e power 0? That is 1. So using this data point, I get this relation. This implies k is minus 2.28. And so that is the question here. Minus is important, minus 2.28. We can also go ahead and find tau. We know YSS, we know k. We can also go ahead and find tau. Just like that biodegradable suture sigma problem, sigma naught, can we not go find tau? By plugging any value here, we can use this value, this value, this value, we'll get reasonably close. Agree? Again, to make things more explicit, just in case some of you are on, you can pick any data point here. I'm going to pick this 2.04 is YSS, that is 2.28, k, that is minus 2.28, e power minus, what is the time value? 0.4 by tau. There is only one unknown here. Can we find tau? Now take things to the side, take ln, you can find tau, right?
Yes, sir.
Yeah, you could have used any point. 0.3 you could have used this. Just that use the corresponding data point. You can't mix 0.25 and 2.04. Okay. So we could also go ahead and find tau. This is very, very important because there is at least one question in the paper based on this. At least one. Usually 2 to 3 marks. So now my question is, and of course notice this question is framed in a very, very general way. You are given too much information and you have to actually start making sense of what is this YSS, what is this K, and then realize you can find that YSS here, K here, and then tau using any of these points. But in general, things will be more simpler. They will give you just, they won't confuse you with so many data points. They will make things easier. They will ask you to solve one equation like this. But let's get to the application. Where is this particular equation is applied in biomedical, or let's make it more focused in GATE syllabus? Can we have some answers? What kind of topics in the GATE syllabus make use of this kind of equation? Okay, someone went ahead and found tau. I don't have the correct value of tau here, but they can perhaps, that might show up in future mock test. But can try in the chat or even like say it aloud. Where is this particular form of equation useful? Have you seen any physical thing following this? Can you think of some examples? This is important because I told you there is at least one exponential type of question, because that question can show up from any topic in the GATE syllabus. How does charging of a capacitor work? How does the solution for that look like? Charging of a capacitor with a, perhaps with a resistor and just a voltage source. How does that look like? First order, right? Charging of a capacitor, charging of an inductor, CR, LR.
Yes, yes.
Yeah, all of these things, even LC for that matter. Let me just confirm that. But okay, electrical circuit, it shows up. Where else does it show up? How does radioactive decay look like? This radioactivity, N is N naught e power minus lambda T and all that. How does that function look like? Again, it's an exponential function, right?
Yes, sir.
Yes, sir.
Okay. How does can you start thinking of other examples? How does usual biomaterial stress strain relations as a function of time depend on some kind of exponential lawn relation, right? Biological tissues have an exponential relation. Okay. Soft tissues. If you look at viscoelasticity, again, it's nothing but LCR circuits will have a first order relationship like this. Can you think of some other examples? How about light absorption in bioinstrumentation? Beer's law. Again, that will be exponential. Okay, that will not have a power of E, that will have a power of 10. But we saw, in fact, we just looked at another example while solving the problem right now. There was one more example.
The diode current.
Diode current,
positive exponential function.
yeah, it explodes. It looks like this.
Yes.
Yeah, this term, the coefficient is, of course, yeah, that's actually a very good answer, because again, from a data perspective, whether it's positive or negative, plug in the right data, you can solve for tau. Diode, actually, it's a good, proper model for diode is exponential. Okay, excellent. That is from analog electronics. We already saw another example here during just solving these problems.
PDX.
Huh?
Probability density functions, PDX.
Okay, there is this exponential probability distribution function. Okay, that is fine. How does attenuation look like? Radioactive decay is one thing. Decay as a function of time is one thing. Attenuation as a function of space. Okay, all this, most of these things in the syllabus, they are all first order. And it boils down to this one equation, making sense out of that. Again, signals and systems, this will again show, because it's a first order system, standard test case for signals and systems, it is there. Ability to solve this problem will easily get you 2 to 3 marks, at least 2 marks in GATE. So take this problem very, very seriously. Okay.
So what about defibrillator? It's not an exponential, but it is decaying.
Actually, a good model for defibrillator will be a CR circuit or something like that. It will be a first order circuit. First order is a good approximation. It will have this relation. In fact, there is one slightly advanced defibrillator problem in Webster. It is first order.
Okay.
Yeah. In fact, if you can go check the defibrillator chapter, the answer will be, solution will be of the same form. Yeah, thanks. The bioinstrumentation example is defibrillator, important example. Again, first order system. Okay, so learn this example, understand this, and you should easily score 2 to 3 marks, which is a lot. People lose cutoff by 0.3 marks and all. Okay, so I'm telling you, you have like 2 or 3 marks right here, at least 2 or 3 marks. Okay. Okay, we spent sufficient time. This question was actually GATE, a 20 question. I have modified it. The answer here will be like, here no feedbacks, it will act like a comparator, whether this is going to be higher or lower. Okay. When the first half of the cycle, it's higher and it reaches saturation. And in the, the input is like this. from here to here, this signal is higher, so it saturates to plus 12 volts. Once it touches here, this grounded value is higher than the input voltage, so it saturates to minus 12 volts. So at this point, it acts like a comparator. What is higher, what is lower between these two terminals? Based on that, either plus 12 volts or minus 12 volts. So signal will look like this. Now, so at this point, the answer I think is this. Then this is a differentiator. We'll get to that, but this is a differentiator. So take derivative of that. Essentially, there is a sharp change here and there is a sharp change here. So if you measure it at this point, it will be this and this. Okay, we'll get to comparators and all that a little later. But pointer, we also have GATE 2020 solutions. Start taking a look at it. Okay, basic block diagram reduction. The point of this question is to, see, someone have mentioned half time and all that, attenuation, half time, decay functions, all there are first order circuits. Okay, consider following block diagram in the figure. This is a very, very thing. If it appears to be confusing, it is actually very, very straightforward. From here, there are two things going here and here. So, why don't we clearly separate those two things? So, there is a G, there is a R G1 here. So, what is here? At this point, it's a combination of these two. In fact, it's not R G1, it's just R. R. What should we get here? R gets amplified by G1, R G1, right? The sum R G1 and R, what should we get here? R G1 plus R. Agree?
Yes, sir.
So at this point, it's R G1 plus R. I think it's R into G plus G1 plus. And at this point, of course, it should be just, amplify this R into G1 plus 1 into G2. And we sum one more signal. What is this signal? Notice we are just taking the original R. So take this and sum R. Okay. And so it's R plus, this term take R common. Or in fact, R goes to the denominator. Let me make things easier for you by writing. What we get here is R plus R into G1 plus 1 into G2. So this is C of S. I just followed this thing. If you don't follow why there is RG1 here, why there is R, we'll have to talk separately, but I just followed the amplification that is denoted here. Very, very simple. I got this. The transfer function is essentially C over R. So C is this, C over R will be, divide this thing by R, which is 1 into G1 plus 1 into G2. Okay. And anything matches here? Yeah, just multiply these two, G1, G2 plus G2. This C. Okay. Very, very simple question. If you have issues actually with y root RG1, y root R, we have to talk, one-on-one. Very basic thing we have to learn. Okay, which of the following source of pertaining to copy or output measurement using demo, dilution, improper handling? If you handle improper, yeah, there is going to be error. Injection time is too long, likely. Method is unreliable for patients. Usually, in general it works, but try a special case. Many of this bioinstrumentation fails. Even measuring heart rate, pulse rate, things will start failing. This SpO2, you put in like 4 fingers, you get like different measurements. Things like that happen with special cases. Okay. Method needs extra precautions in pediatric patients. Yeah, pediatric patients, special gas, you better take extra precautions. Okay.
Sir, first 3 answers will be correct.
First 3 is correct. D is also correct.
Okay.
Okay. D is pediatric patients. You can't just like that go inject some solution into their heart without taking care of how big their heart is and things like that. Pediatric is like children heart is small, right? You can't inject the same volume that you inject in adult heart. One major difference. Okay,
Yeah.
but there are many other things like that. Okay, two systems with impulse responses. Very, very basic question.
Sir, C.
Yeah, see, when you cascade things in the time domain, you have to do convolution. This is, let's say, this is the definition of convolution. Okay, and we'll start from there. If you look at this in the Laplace domain or the frequency domain, it will be a product. So if it's a convolution in the time domain, it will be a product in the Laplace domain. Okay, so things are functions of time. So C is the correct answer. And when we get to what is convolution, we'll try to give a physical interpretation and move on. But for now, let's say this is the definition. Okay, there is an exercise here, flipped activity here. Many of you notice, you just take this second equation, multiply it by 2, you get 4x plus 2y is 12. Come on, 4x plus 2y is 7.
No
There's
solution.
No way it's going to match. So yeah, this has no solution. But here is the exercise for it. Can you modify this example so that we can get a unique solution? Can you also modify this example so that we get an infinite number of solutions? And can you also modify the thing to get exactly 2 distinct solutions?
Yes, sir. Sir,
Yes,
if
sir.
we put an even number instead in place of 7, we will get infinite number of solutions.
Okay, put an even number. Okay, so my suggestion for everyone is try to modify this question. In fact, I talked about this at the beginning of the class. Modify this question to get a unique solution. Modify this question to get an infinite number of solutions. I think there was already one suggestion. And then exactly 2 distinct solutions. Is this possible? Okay, again, try to do this. It's a linear system. You will not find this case. Okay, that is the first thing. One modification I'm suggesting you right away. Second thing, in this case, it was easy to see that if we multiply this by 2, there is a mismatch, there is no solution. But how do we deal with this in general? Say we are given a 3 by 3 system. How do we deal with that? Is there a better system?
The rank.
Based on rank.
Matrices.
We'll
Yes.
take matrix and then find the rank using row echelon form.
Yeah, there is some concept called rank, which will help us move from simple 2D cases to 3D cases, n-day cases. We need to start talking about rank of matrix, rank of augmented matrix, and all that. Give it some thought, but of course we'll cover that in class. But your flipped activity, modify the simple question to match A and C. See if you can match D. I can challenge you to match D, but I don't think it's possible. Okay. Okay, pH of stock fluid. Stock fluid, you all know acidic. So neutral. In fact, this is basic. I will rule it out. Neutral, close to neutral. Again, I will rule this thing out. It's between this and this. Stomach is pretty strongly acidic. So option A is correct. Logic gate in the column. Most of you knew what these gates are. Good, you could answer this. If you don't know what these gates are, now let's introduce the symbols first, what those truth tables are, what the corresponding Boolean expressions are, and then we'll solve this. But for now, many of you seem to know what these gates are, were able to match. That is very good. At least be, for those of you who don't know, get to a stage where you can match these things very fluently. 46. How do we solve this question? Is this the answer or is this the answer? I give
B.
D or B.
Sub B.
Can you type in B for ball, right? We'll again spend time here because again I have some flipped exercises, and there are so many questions to learn from this one question. So where how many of you, okay, can you all type in your current guesses for the answer so that we see like where the class stands? Okay, B, D, D. Okay, so most of you are at least going between B and D. In fact, I'm slightly surprised why D. Even C I might be okay. But the correct answer here is D. unit step response, negative unity feedback system. So we are given a feedback system. We have summation points here. Okay. This is like a control system. There is a gain here. Then we take the gain, we feed it back. It's a negative feedback, so we have a minus here. It's unity. So the feedback here, magnitude gain of that is 1. So I'm not writing that. And of course, what you get here is the output C of S using standard notation. What you put in here is the input R of S. Okay. Now, step response, we want to know the step response. That is,
Sir, if it is having a feedback, then how it is will be the open loop transfer function?
That is the trap in this question. So, for some of you who might know the theory partially, you might have thought C of S is R of S, G of S, and its unit step response. So R of S is 1 by S. Okay, and you might try to take inverse Laplace transform and solve it, but this is incorrect because this is a feedback system. What is given is the gain of the what is given is G of S, the gain of the feedback system. Okay, what you are supposed to do is to remove this feedback, to apply such a thing. That is, you have an input. I'm going to represent this as an equivalent gain. Okay, just like equivalent electrical circuits, we have like equivalent gain. How we do that? Okay, I'm going to replace this with one particular gain, equivalent gain. Okay, how we do that, I will explain later, but this thing with summation and this loop, I'm going to replace it with one box, and then I just get C of S. So this is a transfer function of the closed loop system. That is, I replace the closed loop system with one transfer function. And here, if I write the output as R of S times G E of S, I am correct. And I can take inverse Laplace transform and I can solve the problem. Okay. If you do this, you are likely to get this C, but if you do this, you are likely to get D. Okay, some of you may not follow, who don't know control systems may not follow. It's fine. We'll introduce things from scratch, but this is a major trap here. But given this, can we find the output? Let me go ahead and do that. So C of S is R of S, which unit step response is 1 of S. And how do I find the equivalent of this? This is nothing but, this GE will nothing but G by 1 plus G. This is the equivalent transfer function for this system. Okay, so what I'm supposed to write here is 6 by S plus 5 into do 1 plus 1 by G. I think you will get S plus 5 by S plus 1. Okay, so this whole thing is GE. This thing cancels out. And to take Laplace transforms, I take partial fractions and all that. So I take 6 constant out. I have 2 terms, 1 S plus 11. So it's easy. I'm going to try 1 by S plus 11. Of course, the negative of it, so that S and S cancels. I notice in this way there is a 11 sticking out in the numerator. So I'll divide it by 11. So this is essentially this term. There is a systematic way to do that. I will explain that in the theory. But this is how you do the simplification. And now this is in the frequency Laplace domain, C of t, or output of t in the time domain, inverse Laplace transform of that, C by 11 into 1 by S, it's a constant. Okay, U of t, you can write it as U of t, or just put 1. And what is the inverse Laplace transform of S plus 11, 1 by S plus 11?
E raised to minus 11p.
Yes, e raised to minus 11p. Okay, that is the solution. So the trap here is using the G as such, you will get C. But you have to find G by 1 plus G. which is a transfer function for the closed loop system, and then do this Laplace transform. So we'll look at what is feedback, what is this gain, what is transfer function, how to do equivalent transfer function, what is R of S, what is step response, why is step response 1 over S, and then okay, I did this, how do I go from this LHS to this RHS, that is this partial fraction over here, how do we systematically do that? I did that systematically, then how do I take that inverse Laplace transform? We'll also learn that, of course, going from here to here is possible. You can also go from here to here. Take Laplace transform, you take this time equation, take Laplace transform, you get this function. You have very, very basic questions that covers most of the basic things in control systems. Bonus is the trap here. Okay, again, spend time with this question, try to understand it. We'll start from scratch, of course, but if you understand these questions, you're in very good shape, because you already have four months or something close to that. Okay, couple of things. Can we answer a few other details here? Can we say what is the output at a very large t, t tending to infinity? Can we answer that? We have the function. We can just put t is infinity and answer that. 6 by 11. Can we answer what is this output at 0?
Yes, sir.
Okay. So we can look at C of t and answer that. Can we actually look at this function and answer that question, or look at this function and answer that question? Instead of looking at things in the function instead of looking at this as a function of time, can we look at things as a function of frequency and say what will be the value of this function after a large time, and what will be the value of the function at starting time? Any answers? That is possible. That's another important question from signals and systems, control systems and all that. Final value theorem, initial value theorem. Anyone rings a bell?
Yes, sir.
Yeah, so you could also see final value theorem, initial value theorem and all that. And if you slightly rewrite this, you can start talking about steady state errors, and even error constants, first order, type 1 system, type 2 system and all that. So very basic example, try to follow this. Okay, we'll kind of pick up pace. This is a trap question. So some of you actually not fall for the trap because of wrong reasons. So you thought the maxima will occur at the boundaries. So you tried f of 6 and you got 41. But ideally you're supposed to do f dash of x is 0. This will have 2 roots. And for each root, you should check whether it's a maxima or minima by checking the second derivative. Second derivative is less than 0, it's a maxima. And on top of that, you should also check the boundary points. What is the value of f of 1? Okay, what is the value of f of 6? And let's call these 2 roots x1 and x2. You should find f of x1. You should find f of x2. Out of these 4 values, you should pick the maximum. Some of you fell for this. You found the 2 roots. You found evaluated it. You thought it's 25. Some of you actually missed this. You thought it's at the boundaries and calculated f of x and got it. But this is a proper way to do that. Very standard question in math. Very simple question, but don't fall for traps. Okay, what effect of increasing red blood cells? I'll have to increasing red blood cells. It should increase viscosity.
Increasing viscosity and decreasing pressure.
Both increase, right? Pressure also increase. You stuff something into the blood vessel, pressure should increase. C, right? Okay, I think it's C. I'll verify that. Bayes theorem, a very, very likely, standard question from probability. Typically expected. Solve 5 to 10 Bayes theorem questions. until you get comfortable with that. I have one base theorem question in GATE 2021. So this is a different question. So again, to make things very, very simple, so if it's a conditional probability, you're likely talking about base theorem. Okay. Given this, what is the probability of that? Okay. Okay. Given that the student has answered the questions correctly, what is the probability that student knows the answer correctly? Okay. So use this, call this as one of the conditions as A, the other condition as B. Okay. Set A, set B. What do you want to call here? A is student has answered the question correctly, or to make things answer correctly. Okay, and I'm going to call this as A. So what we knows answer. First thing, recognize it's a base theorem question using this typical keyword, conditional probability. Given something, make that as B. Probability of something, make that as A. Okay. Probability of dashes, that the dash student knows the correct answer, I am calling it A. Other thing as B. Then
answer P of A intersection B.
Okay, this is no. A intersection B and all doesn't come. This is conditional probability. We'll get into that.
A given B.
This is P of A given B. Once you write this blindly, write P of A given B as P of B given A into P of A by P of B given A. P of A. This term essentially repeats. Essentially, you are normalizing this. So take the other thing, P of B given A bar. What if A complement happens into P of A bar? Why this thing and all that? I'll give you a mathematical derivation. I'll give you a physical interpretation. I'll show it visually, graphically, that is as a tree, structurally and all that during the class. But for now, this is the case. Our if we know what is P of B given A, P of A, all this, if you fill it out, we are done. So where is what is P of B given A? That is, student knows the answer, he answered correctly. What is the probability of that? He knows the answer. What is the probability he answered it correctly? I mean, assuming the student doesn't make silly mistakes and all that, this is one, right? He knows it. Can he answer the question with full thing?
P of A 2/3.
Yeah, P of A, student knows the correct answer. Probability of that is 2/3. We already know P of
B 1/3.
Yeah, student doesn't know the answer, so he answers correctly. That is, he guesses and he gets it correctly. What is the probability of that? The probability of a guessed answer being correct is 1/3. Okay, so this is P of B given A bar according to our notation, and this is P of A. And finally, what is P of A bar? What is the probability that student doesn't know the answer? 1 minus probability that student knows the answer. Right?
1/3.
1/3. Plug in these values, you should get the key that I had given here. Fine. Very, very important, probability question. Solve 5 to 10 questions until you get comfortable with that. I'll explain you this. I'll give you a feel for all this formula. I'll show you a quick derivation, meaning, interpretation, and all that. But for GATE, I gave you a shortcut. Call this as A. Call the given condition as B. You want B given A bar B. Blindly write this formula and get the answer. Okay. I'll have to pick up pace. I have half an hour, 15 more questions. How do you solve this question? Power dissipated in a resistor. Essentially, there is a resistor, the current flows through it, there is power dissipation. If you multiply it by time, you get energy. Can you find the time so that the energy is limited? What is the power dissipated in a resistor? IR square. Agree? So this is power.
Yes, sir.
When will you get energy?
E is equal to power into T.
Power into T. Okay, this should be limited. The energy. Okay, this is limited. Is there a limit on this energy, delivered energy? 300 microjoules. Okay, notice this term over here is power, and of course, power times time gives energy. This is given as 300 into 10 power minus 6 joules, SI units. We want the time. Okay, this is the unknown. Resistor is given, I suppose, 600. I is given 10 into 10 power minus 3 amperes. We can find T. Okay, very simple problem. No defibrillator, pacing, this, that, and all that confuses. It says we have a simple resistor model for a defibrillator. If you pass some current, we want to limit the energy in the dissipated in the resistor. What is the time? Okay, I square or T. That's what this boils down to. Fine. Again, this is a GATE 2020 question, and from defibrillators, this keeps showing. Bandwidth. Did anyone not get this? Bandwidth is just change in frequency between this end and that end. I explained this. This is just gamma, the gyromagnetic ratio into GZ into Z. In fact, you should be able to guess this just from the units. This is Tesla per meter, Z is in meters, and gamma notice should be in hertz per Tesla. So you end up with something in hertz, the frequency. Okay, just by looking at the units, you should guess it. In fact, things are made easier because this is in Tesla, this is in Tesla. Sometimes they give one in Gauss, one in Tesla. Basic things, but you know how to solve this, right? At least get the answer here. Okay, my processing is close to 0, so okay, this is an incorrect. Pick the minor trap, typical trap. Pick all the correct options. Pick all the incorrect options. Okay. Basic GATE 2021 questions. Just pick the incorrect options here. Let's get this. Okay, what kind of a problem is this?
Exponential function.
Exponential decay. We have radioactivity at some time is n0 e power minus lambda t. But is lambda given? This is half-life. This goes by t half. Right? So we don't know lambda.
0.3 by lambda.
Yeah, this is ln 2 by lambda. So we can find lambda using this relation. How does this relation show? How do we get t half is ln 2 by 2, ln 2 by lambda?
0.6 not.
Yeah, this is 0.6 to 0.63 something, ln 2. But how do we get this?
N equal to n naught by 2.
Yeah, half-life by definition, starting value becomes half. Okay, so n0 by 2 is n0 into e power minus lambda into t half. Just cancel things, take ln, you should get this expression between t half and lambda. Okay. A very basic relation, but notice it's just a first order system, decay, and as I said, this thing keeps showing again and again. Okay, which is not part of the endocrine system. Thymus, I think, is there. Pineal is there. Pituitary is there.
Sir, pineal gland.
No. This is acne cells of pancreas. Okay. Acne cells is not endocrine system. Okay. I think this is might be related to digestive. Go check that, but it's not endocrine. Okay, while comparing parallel fiber, pinnate, muscle fiber, parallel pinnate, I discussed this and what is this in GATE 2021. The same thing, just make sure to pick the correct option. This, at least I'll explain why this is the case. Okay, CMMR, common mode rejection ratio, it's usually, it's a good, it reduces noise, let's say, very simply. The sensor with the most noise here is is strain gauge. So that's my first match. Okay. At this stage, I will pick between B and C and move on if I am tired. But okay, charge amplifier, voltage amplifier. If I press a piezoelectric sensor, will I get a charge or a voltage? I'll get a charge.
Charge.
And with the pH sensor, minor changes in pH, the electrodes will have a voltage. Okay. So P3, Q2. Okay, what kind of a question is this?
Again of the same type.
Yeah, n is n naught e power minus lambda t. Just make sure you know calculate t. All of you are able to calculate t, right? There is 1 day in between, so it's 24 hours plus time from what is this? This is 4:30 p.m. the subsequent day, next day. And when do you start? 10:30 a.m. So 10:30 to 4:30. How many hours are there? Can someone help?
6.
Yeah, 6 hours, and it's a subsequent day. So I add 10 hours, and this is in seconds. So convert this also in seconds. 1 hour is 60 minutes into 60 seconds. This is T, lambda is given, and n naught is given 6. Okay, straightforward question. Another straightforward question. Aseptic loosening. Yeah, there is no infection. Aseptic, there is septic, sepsis, infection, inflammation. Fretting fatigue is progressive deterioration, and shielding. Yeah, this thing. Okay, again, straightly a gate question. How do we answer this? Some of you know this. Can I explain how to answer this? There is one keyword we should be careful about. This is a interesting gate question because you cannot solve for
Current
it.
convert into voltage.
Yeah, current convert into voltage, not necessary for this problem. This is a very interesting gate problem. Sorry?
This given can be the value of the current source. Right? So
yeah, which can be, this is an interesting, which of the following is the value of current source is not the question. Can be is very, very important word here.
Options can be used over here.
Yeah. Okay. In fact, thanks Fernando. This is a very, very, very important keyword here. What can be the answer here? They are not asking what is the answer here. Very important difference. By that they mean they are not asking you to calculate the answer. They are asking you to look at each answer, stare at each answer, stare at the question, stare at the figure, say if this is possible or not. Can it be an answer or not? Okay. Very subtle detail, but very, very important. Thanks. Someone mentioned this. The second important detail is absorbing power. When a source is absorbing power, usually we have a source here, current goes out of the source. When it's absorbing power, current gets into it, a positive current flows this way. Okay, so now something positive flows here, we get 12. So what should be I? You take I, add something, you get 12. So I can be less than 12, right?
10.
Yes.
Yeah, is this less than 12?
Yes, sir. Yes, sir. I less than 12.
No, I should be less than 12 because this is positive. Why it's positive? This term over here, absorbing power. So 10 is the correct answer. Notice they asked what can be the answer. You have to rule out the options and answer. Okay. So this is a gate question. Gate is actually forcing you to eliminate answers and answer. So we are mixing logic with basic, basic theory here. Aptitude with electrical circuits. Very interesting question. And great. So many of you are getting it. So start noticing subtle details. Okay, we add things. So basic things. So how many of you recognize this is a summation going on here? Any of you recognize that? Raise hands or a voice, please. This is a summer.
Yes, sir. Summing amplifier.
Okay, great. At least some of you recognize that. And when we sum things, should we give more weightage to this B7 to B4, which are like most significant bits, or more weightage to this?
MSBs.
Huh? We should give more weightage.
MSB.
Yeah, MSB. We should give more weightage to MSB. Okay, that means the gain of this summation should be higher. Gain is in this circuit, again, it's an inverting amplifier, each part. So it's 8 by R. That should be higher. How higher? There are already 4 bits. So it should be at least, not at least, it should be 2 power 4. Okay. This would say R is 8 by 2, which is 0.5. Okay. This is one question. We'll get to theory later, but recognize it's a summing amplifier. The MSB should have a higher gain, and the gain here is just 8 by this resistance here. The gain here is 8 by 8, 1. Okay, and these are already, it has gone through a DAC. Now the summation is what should be properly accounted for. And what is DAC, what is summing amplifier, what is MSB, what is LSB, we will get to it in theory. Okay, for now, let's skip this. Some of you made mistakes in this question. Not acceptable. Okay. Not at all acceptable. Okay, another example of a question where it might look okay, spring mass dampener. I know electrical circuits, but I don't know spring mass dampener. I'm going to skip this. Is a bad idea. Just look at the question. They say, given a differential equation, can you find the transfer function? In another simple words, given a differential equation, can you take Laplace transform of that? Okay, that is what this boils down to. Take Laplace transform of this differential equation, m s square x of s, okay, plus d s x of s plus k Laplace transform of x of t, x of s. Laplace transform of f of s, f of t is f of s. What we want is x of s by f of s. So x of s by f of s. Take f of s to the side. Notice you can take x of s common, so take everything else to the other side. M s square plus d s plus k. And there are no factor of s in the numerator. This is ruled out. This is ruled out. And notice s square is there in the denominator. This is not possible. No, things are not there in the numerator. Things are there in the denominator. This is the answer. In fact, you can plug in given values and verify that, but you can answer this is correct. Maybe the detail here is Laplace transform of second derivative is s square x of s. Laplace transform of first derivative is s times x of s. Very basic detail. If you do not know it right now, very, very basic, get to know that. Okay. Of course, when you start Laplace transform, I will at least give you the formula, basic formula for this, just in case you didn't know this. 816. Okay, size A of the surface flaw in a glass is this. Okay, surface flaw. Which topic is this from? What is this topic?
The value putting.
Sorry?
The value putting.
Okay. The type of question is value putting. That is pretty much a formula is given, values are given, substitute and find, use the gate calculator and find the numerical value putting type. But where is this question from?
Biomechanics.
Biomechanics and
Biomaterials.
Intersection. Yes, intersection of biomaterials, biomechanics. Even if you did not know that, realize formula is given, everything is given, substitute values with proper units. With proper units is I should write it separately because students have actually problem here. Silly mistakes, most silly mistake happens with proper units. That is micro, I should do 10 power minus 6, and then gigapascal. What is Pascal? Should I keep it as such? Giga, at least I know 10 power 9, but Pascal, what is it? I have a Pascal and a kilogram per second square. How do I deal with these two combinations? Questions like that arise, most silly mistakes happen there. So put values with proper units and read the question. Actually, I wanted to say one more thing. I left my train of thought. But yeah, if you didn't know biomaterials, you can answer this. Yeah, the second detail is you should start using gate calculator. It might look silly right now, but it's extremely important. Doesn't matter if if you know this is a value putting type. If you don't know to use a guilt calculator during the exam, you cannot answer this. Okay, so we have 2 or 3 questions. We'll finish in time 8:30. I suppose all of you were informed, right? Class will start 5:30, will go till 8:30. Right? Just in case some of you are surprised, when will this finish? I hope I sent a warning. We'll go till it's a 3-hour exam. At least we'll discuss it for 3 hours. Okay, we'll finish in time. How do we solve this? Again, a question that looks complicated. You may not realize whether it's from signals and systems or whether it's from medical imaging or whether it's from mathematics. But another question, if you read it, you can answer this. What do we want M of F? That is modulation.
Data communication.
This is actually from medical imaging, basic signal processing in medical imaging. The data processing is closely related. Yeah, modulation happens in data processing. Data processing is specific to signal medical imaging. In fact, this is from Prince and Prince. Okay, we need M of F, modulation. Is M of F given? Modulation is given as this thing. F max minus F min by F max plus F min. There is some function, difference between maxima and minima by sum of maxima and minima. So the function is given. Now, what is
amplitude modulation we have to find?
Amplitude modulation, signal amplitudes, all that is fine. In fact, things are defined here. What is modulation is defined here. We want M of F, that is, we want this term. Question is, so we have F, we want maximum of F, take that, subtract from minimum of F. And the denominator, we have maximum of F plus minimum of F. Okay. So M of F is this, and F is given. So the question boils down to, can we find F max and F min? That is, we are given a function, can we find its maxima and minima? What is the maximum of this function? Differentiation, again, okay, that is proper mathematical way to find the maxima, but what is the maximum value?
So it will depend on the value of the sine function over there.
Yeah.
Plus 1 and minus.
Yes, thanks for naming. What is the maximum value of sine function?
1.
What is the maximum value of 2? I multiply sine by a
1.
Thanks. So 1 second, let me just write this down so that all of us follow. I want maxima, minima, and my function is sine. What is the maximum value of sine function? 1. What is the minimum value of sine function?
0.
0. Minimum sine function?
0.
Minus 1.
Minus 1.
Minus 1.
Minus 1, right? Okay. I take the sine, I scale it with a constant. B sin x. What is the maximum of this? I just multiply sin x by a
B.
B. What is the minimum of this?
Minus B.
B minus B.
Now I add a constant to this. What will happen to the maximum?
A plus B.
Yeah. So which is the function we have here. What is f max?
A plus B.
A plus B. What is f min?
A minus B.
A minus B. Thank you. So can you find f max minus f min by f max plus f min? Yeah, if you do f max minus f min, a's will cancel, b will remain. If you do f max plus f min, a will remain. 2b by 2a, this is the answer. Okay. In fact, the formula is given, but yeah, this is maxima, minima, using logic, not don't do derivative and all that. Sine function, I know maxima is there. Exponential function, I know it kind of goes like this. Domain is not specified. I know where maximum, minimum. That level of math, ability. Okay. Very simple question. Again, once we see the answer, things are like Yeah, you could have answered those. Pointers in GATE, if questions like this show up, practice enough, prepare enough to answer them. 64, 65. Okay, I'll deal with 65 very more simply. Okay, what is this question? So how do we go from here? How do you find this integral? Given this, given over here, x of t is given. We say x omega is a Fourier transform. All of a sudden, we want some integral. How do you find it?
That is the area under the curve of x
Area
omega.
under the curve, something like that. Can we relate? Okay, Fourier transform, something like that. Can we do area under the curve? There is an integral. Yeah, area under the curve, but which curve? So to start making sense out of this, we have to write from x omega, how do we go to what is given? That is x of t. That is one line of thought at this point. Or what is this integral closely resemble to among the things that I know? Okay.
Inverse Fourier transform.
Yeah, notice this integral is very, very close to inverse Fourier transform. Okay, so close
And
that
then
I'm
we
going
put t equal to 0.
Yes, I'm going to, it is so close that I'm going to write that down. Inverse Fourier transform, that is given x omega of t, I can find the inverse by, or the definition of inverse Fourier transform is this: x of omega e power j omega t d omega. This is a definition of inverse Fourier transform. By that I mean, given a function in frequency domain, I do this integral, I get the function in x of t. And why did I write this? Because this is so temptingly close to the integral that we want. Okay, because it is temptingly close, I wrote that down. Some of you by now found the answer, but others who are trying to catch up, can you find this integral here? That is, how is this integral a special case of this relation I have written here? What is the difference between this integral and this?
The value of omega is 0 in this case. In question,
value of t is 0.
Yeah, you're close. Omega is 0. If you put omega 0, now you will go to x of 0 d omega. That's not an integral. Okay. Notice, but if you put t is 0, this e power j omega t disappears. We want it to disappear so that we get back the integral we want. We wrote something very close. Now time to make it the actual integral. How do we make it the actual integral? If t is 0, this thing disappears. So x of 0 is the integral we are looking for. X of omega d omega. Agree? So what is the answer here? What is x of 0?
sir, 0.
1.
1.
Yeah, x of 0 is
sorry.
t greater than or equal to 0 e power minus 0. That is 1. Okay. So yeah. Okay, this is like, okay, how do we know from this integral? I should know if we are actually looking at x of 0. I explained my line of thought. I sense something fishy here. This is there is a trick. This is a trick question. I sense it. I partly vaguely recognize this integral. It is very close to the inverse Fourier transform. Oh, it's actually a special case of that integral. I just put t equal to 0, it disappears and I get this integral. Oh, it's just x of 0. That is a line of thought. Okay. Okay. I'm actually, I wanted to solve this fully, but I'm going to use a shortcut. So in the numerator, there is a, how does two gains add up? G1 plus G2. Agree? These two add up, these two gains.
Yes.
Is there any term here with G1 plus G2? This has G1 plus G2. This doesn't have G1 plus G2. This doesn't have G1 plus G2. This doesn't have G1 plus G2. No, close to the exam, I have like 5 seconds left. I'll choose option A, and I'll choose option A. Probably the exam will close. How do I solve this? This system, okay. I'm going to draw some circles. System 1 is G1 plus G2. system 2. Now we have a gain G1 plus G2 with a feedback. Okay, we already noticed something similar, G by 1 plus G, but their feedback was unity. Here we have a non-unity feedback, H1. What do we do about that? So this is for 1, gain of 1. Gain of 2 will be G1 plus G2, that is, take this gain and same thing, 1 plus G1 plus G2. But it's non-unity, so I have to multiply it by the feedback, H1. That is for this circle over here. And having written this circle is very, very simple. G3 is very simple. Oh, things are cascaded. G3. That is also simple. So, in fact, let me extend G3 here. G3. Okay, now can I do the full transfer function, overall transfer function? Oh, this is just, I have a big equivalent G here. I have a unity feedback. I know how to reduce it. This big G by 1 plus big G. Okay, that is G plus 1, G2, G3 by 1 plus, again the big, the denominator is calculus, so I'm not going to write that. G1 plus G2 into G3, then there is this term over here, plus G1 plus G2 into H1. Okay, I think I have written this correct. You could go, in fact, I have the answer here. Yeah, take G1 plus G2 common, there should be a plus 1, okay. You should get this, you should get A, but as I said, last question, I have 5 seconds left. G1 plus G2 should be there in the answer. I'll rule out all this, pick A, and I'll do it. Okay, great. So we started with 22. In fact, we started with less than 22, and we are still with 22 students. Great. Oh, there is one more question left. Yeah, plug in these values. Now we want feasible values. Can this be an output question? Okay, so just check for each. This should be possible. This should be possible. This should not be possible. This should not be possible. I have already tried this in the gate VM, so I'll skip this. Okay, time to finish. 8:30. 3-hour exam. Typically, how you handle this? Perhaps not the way I handle. I will also give a sample of that. Like I'll try to solve an exam in real time. So that you see how things move on. But this is what typically happens. I really, by this time, you do this, you do this exercise. We gave the answers today. Also, I'll put the key in the Google form. Towards the end of the form, I'll add a link to the key so that all your forms, you can go back to your form and check it again and again later, 6 months down the lane. Okay, so I'll also add a key to the bottom of the form so that you know what the answers are. We discuss the solutions here, and flipped activity, modify and frame new questions. How? We discuss some examples. This is a nice exercise to understand gate questions. Also, along with mapping questions, it starts helps us understand the syllabus. So now we understand the question paper pattern. We understand the type of questions, marking, and all that. It's time to get a feel for actual gate questions. How they set questions. Best answer is start framing questions that are similar. Start modifying questions. We discussed examples. And best way to start understanding the syllabus is by mapping the questions that we have discussed so far. And remember, we just don't have 2021 paper. We also have 2020 paper and solutions. Okay, I'll mail you. We are close to finalizing admissions. I mail you. So have a good one, and stay safe. It was a wonderful class. Even teacher is physically there in the class with 10 students, 15 students. It gets hard to handle. You have been amazing students. courteous to the class, courteous to everyone in the class. Thanks a lot for that. These 22, I'm sure we are going to have an excellent, we'll have an excellent class. So there are some who missed the sample class. I'll have to talk to them, but we'll have a nice class. In fact, I was wondering if 25 is manageable. My answer is I noticed it is possible. So I am looking forward to an excellent, excellent academic year, and I'll mail you the details. Fine.
Yeah, sir.
Excellent. Yeah.
Thank you, sir.
Yes. Yes.
Thank you, sir.
Thank you,
Yeah,
sir.
yeah. Welcome.
Thank you, sir.
Thank you, sir.
Yes. Welcome, everyone. One detail. In fact, I said this physical presence. Yeah, we are getting into the orientation class. There is physical presence here just because we are interacting, communicating over internet doesn't mean we are not sitting next to each other. Okay, important point. Recognize, I am here. I am someone with a heart, someone with a brain, 2 eyes sitting here. Same goes with you, whoever is listening. Recognize there are other hearts and brains, here, right here, physically interacting. Very, very important for this class to make friends. Okay, not a regular online class. This is actually very, very special. You might have heard this Microsoft Mesh and all that, but our technology is far more advanced. Okay, we physically interact in the class. That will be my what is it, cliffhanger for the orientation class. I hope to see you all again, and then we'll wind up. Have a good one. We'll contact in chat or email. Okay, excellent everyone. Okay, have a nice one. Stay safe.
Thank you, sir.
Yes, yeah. Bye.
Thank you,
Bye.
sir.
Bye. Bye. Bye.
Thank you, sir.
Thank you, sir.
Bye, sir.
Yeah. Bye.
Thank you, sir.